understand.
Yes.
Can you clarify again? Can you hear me?
Yes, please go ahead.
Can you clarify again about the hard parsing and the soft parsing, please?
Hard parsing just means the execution plan of the query or the explain plan of the query has to be created again by the optimizer. So we have a program that runs in the database called optimizer. So whenever we are talking about hard parsing, it means that optimizer has to create a brand new explain plan for your query and store that in the share SQL area. And soft parsing means the plan has already been created and the query will just use, the optimizer will just try to find an existing plan for your query and just assign it to the server process and you can use it.
Okay, thank you.
Yeah. So one, hard parsing, it has to create it again, and soft parsing, it already exists. You just have to find it. Does it make sense?
Yes, it does.
Good.
Thanks.
I have a question too. When the request enter the server by the user process, before the server process accept that request, does the optimizer accept that request for us and look for that execution plan before the server process decide to do the work?
Now, the optimizer comes into place after the server process brought the query to the shared pool. So till the server process comes to the shared pool, then we start talking about optimizer.
Okay, thanks.
Yeah.
And another question, quickly.
Yes, please.
We mentioned about the big file tablespace last time, and you said we can increase it. How can you convert it?
You can look for it in Google, right? I think it's possible if you want to convert it, okay, into a small file tablespace. You can find steps on Google all over the places. So
Right.
you just have some steps to follow for that.
All right, thank you.
You can create a small file tablespace and you just move all the data that is in a big file into the small file. So that's very easy for you to do that.
All right.
Yeah.
Thanks.
No problem. So, any question? All right. So, I think again, as I said, I want you guys to keep this one somewhere in mind. Okay. You should know that you should know how a SQL statement, how whenever you issue a GML, how it works. I think I explained how a select itself works. Okay, this one is a GML. For the DDL, some of these steps may not be, may not be present, like the undo. The undo, may not be created for a DDL because a DDL you are creating the object. Maybe if you are doing a create statement, a creatable statement, okay. An undo is not created because automatically the transaction is committed, okay? So you may not have an undo that's created. And for the DDL, you don't have parsing, okay? You don't have soft parsing. All DDL always go through the hard parsing process. So you will never say that the optimizer has a plan stored somewhere for the DDL, okay? So all DDL always have to go through the parsing process. And DDL are not really big queries. So the ones use a lot of resources like GML. because you will run some update statement that joins multiple tables at a time, or some select statement that join multiple tables at a time. That is what makes the query becomes resource intensive. But most of the time, simple queries don't need to use a lot of resources, like whenever you want to create an object, okay? It doesn't need to, the hard parsing process won't be that expensive. So that means in an interview, you are mostly expecting this GML, okay? GML or select. Select will stop at some point here. Data dictionary cache. After data dictionary, you will not have all this stuff for the select. So all these steps are for the GML. So it's better for you to know at least some of these high-level steps. When you are talking about the life cycle of your update sticks of a GML, you should make mention of few of these. Maybe you can forget one or two, but at least you have to make mention of them. You have to make mention of share secret area, data dictionary cache, undo, locks, and maybe redo that is generated. So make sure you have it documented somewhere. And today, we will now go a bit more into the tuning part, okay? The architecture, each time I will be explaining something, you will see that it was really important for us to introduce again, to start again the architecture, because everything, all performance issues at the database level, okay, or all SQL issue, sometimes it can come from the way the database is designed, or it can come from one of the components of the architecture. So that's why I started with this. And from this architecture, you will see where we can have performance issues. So it's very important for us to keep this architecture in mind. So the first point is, when do we need to tune, okay? Even though the PowerPoint, again, you can write your question down as you say, right? When I will open the floor for questions, you can definitely ask your question.
Okay.
Yeah, even though this PowerPoint is, is I can say in majority, right? This PowerPoint is focused on SQL tuning, because you'll be frequently exposed to that. But it doesn't mean that I will be talking about SQL tuning only. So while talking about SQL tuning, I can also bring up the database tuning or system tuning, depending on where I am. For instance, when it comes to when to tune, okay, I told you guys last class that performance issues can be at different level, okay? It can be at the network level, it can be at the system level, operating system level, it can be at the instance level, it can be at the database level, it can be at the application level, okay? Different level. So you decide to tune basically when you notice that either of those are affected. So meaning what? Meaning when it comes to a database, for instance, if you notice that you are receiving a ticket, okay, you receive a ticket on a buffer cache full, a memory full in the database, then you may decide to take action. If you receive a ticket on maybe the PGA, which is the private global area, full, that means you may need to fix that, because whenever a PGA is full, all the transaction, all the private, okay, all the transaction that need the PGA, okay, they will hang, definitely. So user will start encountering some slownesses. So a PGA full can lead to performance issues when it comes to SQL statement, or also at the database level. So You can also have a database performance issue, maybe because the location of the archive log location is full as well. Because every transaction, as we saw on the life cycle here, right? We saw that whenever you are running a GML, it should generate a redo. So that means if the redo log location is full, where is the database going to write the redo? Nowhere, right? The database will also hang. So meaning normally users will start encountering issues because their transaction won't be able to generate redo because there's no space to store them. And that will cause their code to fail, okay, or to hang. So that is a performance issue that you are having, okay? And that will cause not just a performance issue at the SQL level, but it can cause performance issue at the database level. Also, if the same location is full, that means if the entire FRA is full, all right? So it means that the database, again, all the backup can also fail because those backup may need to go to that FRA, okay? And when it comes to the system level, if at the system level, the total memory is exhausted, okay? If the total memory is exhausted at the system level, then swap space may start getting used, okay? And let me tell you how the swapping process works. Normally, when you have a system, okay, when you have a server comes with certain amount of memory, a certain amount of CPU, okay, by default. It comes with that, those components, processors, it comes with that. Now, you may decide to use all of them, or you may decide to partition them. And to partition them, you may need to use something we call the hypervisor software, okay? You partition them into small, that means you take memory and you split it into smaller chunks of memory. Like you guys, you are servers. Do you think student 100 and student 101, do you think you guys have your own server? No. We have a general server that comes with more memory, more CPU. And we install an hypervisor on top of it and we virtualize it such a way that we can split those memory into smaller pieces, okay? So now each of you may have equal amount of memory allocated to you, an equal amount of CPU, an equal amount of processors, okay? So now, whenever you are using your memory, okay? If, for instance, for any reason, your virtual machine is highly used, busy, or is highly loaded, meaning a lot of people are accessing, or a lot of transactions are taking place in your memory, in your virtual machine, okay? Definitely that can also increase the memory usage. And if the memory is exhausted, we also have something called the swap space. That swap space is, in general, is the memory provided by the disk now. So that means the certain amount of memory you can grab from the disk, so that that memory will be a backup of the main memory. So you can see the swap space at the operating system level. When you guys issue top command, I think I opened the terminal for the morning class. Let me see. Okay, for the morning class, I opened. Is it active? Okay, yeah. For the morning class, for instance, I opened just a basic stuff you guys know, okay? You guys know how to issue a top command. And this is what I'm talking about. So you guys saw something like this, memory. You guys have something like this swap. So this memory is what you guys, this is what all your resources on this server, all the resources on this server 367 are sharing. This is the total amount of memory available on this virtual machine. And this is what is used, this is what is free, this is number of blocks. So this is what everybody is sharing, but sometimes we also need swapping. Swap space is actually what you are getting from the disk. So it's the memory you are getting from the disk, from the storage. Now, such a way that in case this one is exhausted, transaction can get memory from the disk, from the swap space. But what happens is that it's not advisable to have swapping frequently, because if transactions are getting their memory frequently from the disk, that can degrade the performance. Let me take it. Let me take this example. For instance, I have a total memory of, I took smaller number so that it makes sense. Total memory of 50. So that means at the memory of my system, okay, at the database server is 50. The memory used, for instance, up to now is 47. The amount of free memory is 3. Let's take a megabyte or kilobyte, okay? Take the unit that works for you, just for demo. And I have a query. The query wants to use 5, I don't know, maybe it's megabytes of memory, but we have only 3 megabytes free. Without the swap space, this query won't have enough memory to get executed, okay? You may need to wait till some memories here are released, okay? So what happens is with the swap space, the query now, because the query needs 2 more megabytes, okay? It can grab those 2 megabytes from the swap space. So you get the 3 remaining one from the memory plus 2 from the swap space, so that you can make the 5 megabytes the query needs to get executed successfully. But the difference is that the swap space, even though you guys can see that at the OS level here, it is actually a memory provided by the disk, by the storage. And the storage and database server can be different. So we can have a server only for the storage and a server for the database. So meaning the database server, the instance, where the instance is running, right, can be on his own server. We have a network, and we have the database where we have data file, control file, and so on. So meaning we have a network somewhere here. So meaning that what we are actually doing is that the background process, the kernel may need to go, the kernel program may need to go to the storage, grab some memory, and come back to the server again to provide it for your query. So that but the time is taking to go to the storage, grab some memory, and come and give it to you is expensive. That is what we call swapping, because for you to get the memory you need for your code to be executed, so that memory has to be retrieved from the disk before before you can use it. But the other memory is already here. You are not going to the disk already to get this one. You're not going to the disk to get this. This is what you need to get from the disk. So it's just helping you in case you don't have enough here. So you can grab it from the disk. That's one of the biggest usage of the swap space. So, and it's not mandatory, okay, to have swap space. You can configure a VM with no swap space 00, but it's always good to have some swap space. And it depends on the company, okay? Without swap space, there are some transactions that really use swap space, that need swap space. And those who have done system administration, they can tell you more. For instance, I've used swap space. I've increased the swap space. That is not a GBA job, but I've increased it because whenever we were updating some packages at the operating system level, the swap space was going to 0 because it was very small. And because it was very small, it was going to 0. Some users were affected. For any reason, some users were affected because the swap space was 0. So what we had to do was just to increase it to a bigger size, so that when we are doing that deployment at the operating system level, the swap space will not go to 0 and multiple users won't be affected. So just understand this one this way, okay? So that's why on the PowerPoint, I made mention of swapping. So the database performance, okay, can come from a lot of areas, okay, as I made mention of. Either we are deploying a new change on the production, okay? Let's assume that on the production, we are running a new code, or we are updating an existing code from the production that can cause performance issues. For instance, let's take an example. Let's assume we have a code running on the production now. That code is actually a package of your WhatsApp application. And what is that package now? A user is trying to update the package. Okay? We want to update the package. We want a new version of the package because the new version is coming with new features. Okay? Let me take an example. Let's assume that the previous feature of WhatsApp, of the application WhatsApp, okay, that the package that's responsible for certain functionalities. Let's assume that with the previous feature, or with the previous version of the package, you were not able, whenever you send a message to someone, you cannot delete. Okay? That's an example. That is how WhatsApp was working before. So you send a message to the wrong person, or you send the wrong message, you want to change it, you can't change it, okay? You can't hold back. You just have to apologize. You just have to say something else. That, hey, sorry, wrong person, okay? That's what you were doing before. But now, let's assume that somebody now we say, okay, we want the customer to have a better experience. And now we try to update or to tune that package. So we try to add some new features on that existing package. Now, once we add that feature has to be deployed on the production. That change has to be deployed on the production. The developer may not do it directly because all of them may not have the permission to access the production, but they may send it to you and you will run it, okay, through some tools. We call that push request. So they may send it to you and you will run it, okay? So now, once you will run that change, before you even run it, you have to make sure that that change will not affect the system negatively. You have to make sure that they tested it. You have to make sure that by running that new change on the production, that will not degrade the performance of the system or the database, sorry. So that is something that you have to pay attention to. So when you will run it, before you even run the change, you check the result of that change on the lower environment. Then you can now run the change on the production. Now that change, despite the fact that the change maybe was working perfectly on the lower environment, you can deploy on the production and you still have performance issues. So meaning that by someone changing the application code can lead to performance issues as well. So if yes, it's true that you are having that new feature now, okay? Now you can delete the message. That is good. But maybe now the new change is now using more memory or more CPU than the previous package, okay? So meaning that whenever we are having code change, it can lead to performance issues. So, and that can affect the entire database, not just one query, but the entire database. If you are also in an environment where the table has grown in size, the table grows in size, okay? If the table grows, maybe we are dealing with an environment, a database of 2 GB, and so the database is growing. The database, okay, is growing in size, and it moves from 2 GB to 8 GB. Of course, you may start having some performance issues, or you may try to create, okay, to be more proactive, okay, or to create some new object in order to reduce performance issues. Let's assume that you have a table that was smaller before, but it has grown in size. That means the way the optimizer was calculating the plan before may not be the same way because the data has grown. The way the optimizer was helping you to access the data can be different now. If before you were having a table with 100 rows, and now the table has grown up to 1 million rows or 100,000 rows, the way you were accessing the query before may not be the same way you will access the query now. So something can change, and the performance can degrade because of the data growth. Okay, so the data growth can affect the performance. That is why big companies always like people who work with big databases. Because whenever you are dealing with a big database, that means you are also dealing with huge problems. The bigger a database becomes, more difficult it becomes for you to manage it. So the data growth can lead to performance issues. And that is why you will find yourself creating indexes, partitioning, and so on. But again, in very big environment and critical environment, whenever you, the GBA, you identify the need of an index, you don't just create it, okay? The developer will always create that. And you will and send it to you through a push request, and you just run it on the production. Or even also the partitioning, okay? We'll be talking about this in a moment. So data growth can cause performance issues. Application code change can lead to performance issues. Database parameter change can lead to performance issues. Meaning that you have database parameter, you guys know a lot of database parameters, okay? You are changing a parameter, or you don't have you have maybe a small share pool. If you have a small share pool, of course, that leads to a small share secret area. That leads to frequent hard passing. Because the share secret area is very small, a plan won't be kept there longer. Okay? The plan will be flushed out faster than if the share pool was bigger in size. So because of that, that can lead to frequent hard passing. And frequent hard passing just means that you are giving a lot of work to the optimizer every time to create a brand new plan for you. I will talk about the optimizer after this, okay? Very, very soon as well. So that is, and also we have multiple parameters that you can be changing in the database. If you don't set the process parameter properly, okay? Once the number of processes is reached, nobody else can get in except you, but no other user can get in. So you have to find other techniques. Okay, so the DB parameter change can affect the performance. It can increase it or it can reduce it. Not always reducing, okay, but it can also increase the performance. The upgrade and the patching can improve or degrade the performance of a database or some queries. What is an upgrade? An upgrade is like you are getting something, you are going to a higher version than the previous one. You are using now a Samsung Galaxy S4. Now you decide to use the S5. Even though most of us, we don't know the feature, the important feature of that S5, but you are upgrading from the lower version to the higher version. Why? Maybe because the higher version is more powerful. Maybe because the higher version is more performant. Sorry, okay? It has a better performance. Maybe it has a better, you can take better pictures. Maybe you can take better videos. Maybe it has more storage. You know why you are going to a higher version. You know why you are buying a new phone and so on. Okay? You know why you're upgrading. You're upgrading because maybe the new one is more performant. Okay? And so on. So that is why you will find yourself upgrading. Maybe because on the new version, there are new features that the previous version do not have. We have new features you want to take advantage of. Maybe on the new version, we have more security when it comes to data. Maybe on the new version, you have better performance. That is why you decide to upgrade a database. That is why on the project, we are going to upgrade the database from 11G to 12C. Show you how to do that, because that's something you'll be doing in your environment frequently. Okay? And upgrade always go with patching. So this is the second project we'll be doing after data guard. Okay? So, and why upgrading or patching a database? Some feature can work perfectly. Some features can improve in performance, okay? But some other features, a couple of them, a very few of them can degrade in performance. And I can tell you that more than 99.9, more than 90% of the time, some queries will start running slower than before, while others will start running faster than before, while others will stay as they were before. So meaning that an upgrade doesn't always mean that everything will be working perfectly or better than before. Some features can be affected, or some features can degrade in performance when it comes to database. So it can lead to performance loss. And when we do upgrade and patching, I will tell you how we can resolve some performance issues due to the upgrade and how to identify it. So yes, pretty much we have multiple reasons, multiple things that can bring you to database performance loss. Again, I took some couple of examples, okay, now, and you should then know that performance loss can be at all those levels I made mention of. Okay? Any question? Question, please. Does it make sense what I just said?
Yes, I have a question actually. So
Yes.
you mentioned that when you're doing the upgrade, sometimes it might not be all that beneficial. So are there things that in the upgrade that you can change to make it suitable for your environment? Like for
Again,
instance,
I did not say upgrade is not, the upgrade is something that is requested by the application team most of the time. Okay? Or I will give you the reason of the upgrade. There are multiple things behind an upgrade. For instance, because applications connect to databases, you can receive a request from the application team that database has to be upgraded because our application we just upgraded our application, and our application will work better or will work best with the new version of Oracle software or Oracle database. I want it to make sense. So you may decide to upgrade because you are receiving a request from them. Or you can even find yourself upgrading because you want to keep your support from Oracle. Oracle will tell you that by the end of this year, I'm no longer supporting 11.203. That is even what is happening for the end of this year. So you have to go to 12C, you have to go to 18C, you have to go to 19C if you still need our support. Otherwise, any issue you have, we will never help you. Okay? So I will give you multiple reasons behind the upgrade. But what actually happened is what? Once you upgrade, a lot of features will improve in performance. I'm not saying that you can get to a scenario when the degrade in performance. No, most of the time, whenever you upgrade in your environment, because Oracle will provide you a README file, they will tell you how to upgrade depending on your platform, depending on your system, your operating system version, and all those stuff. Once you upgrade, the majority of features will improve in performance. Some of them will be stable, nothing will change. They behave as they were before. But a couple of them, not that much, can degrade in performance. Couple of them. Now, you will now focus on those ones who degrade in performance, okay? Only those ones that degrade. The ones that are working fine, you are good with that. Now you have to find the GBA. Whenever they are doing their application testing, you are the one now to help on how you can fix they poorly, those SQL statements that are now running slower than before. And you have technique for that, okay? There are some technique to fix it. After the upgrade, you can fix it. Before they start using a new database, you can fix it. Does it make sense?
Yeah, it does. Also, if you can please bring back up the server that you opened. I wanted to know on the memory. You said the first one, the total, that's the total memory allocated. The second one is what you've used so far, and the third one is what you have available. So what's the fourth one?
The number of the blocks, buffer blocks. The total number of blocks.
But would that not be the size, like the same as the size?
Which one?
Total number of blocks that you have available, or just in general?
Total, not general. If you want to see the number of free blocks available, you can issue the free command.
Oh, okay. Okay.
The number of blocks that are cached already, or the free one. Can use the free command. This just give you the total.
Okay.
So some metrics are really important whenever you log into a server. The load average, very important. That's why I told you guys, if the system is highly loaded, performance can degrade because of the load on the system. And you guys can take a look. You can try. If we are, I think, if when you reach out to when it's 11 p.m., okay, you can issue this command. You will see that the load has increased. Because the load has increased, that is why you're having performance issues. Because at that time, there are some jobs actually running. Okay, so maintenance job scheduled to run at, I don't know, I think from 10 p.m. onward in Brontech. Okay, so by having a highly loaded system, it can definitely affect the performance of the entire server. Okay.
Okay. So I have one more question, and this is not actually on this page, but I think 2 pages before. I wanted to know, so the SCN number, is that only created when you issue a commit statement? Yeah.
Not only when you issue a commit statement, but after a transaction is committed, yes, for sure, the SCN is written, but also the SCN number can also, change whenever there are some checks on the data file level, data file header level. It can also be updated. But in general, you will see an update whenever a transaction is committed. So once you issue commit, yes, for sure, you can also see the SCN number to change. And it actually determines, the point at which, you can perform the recovery up to that point.
Okay, thank you.
All right, so one of the critical element of tuning is the design. A database should be well designed if you don't want to have performance issues your whole life. Once the database is not well designed, you can find yourself deleting that database just because you want to save your time or your energy. That's why the most critical part is the design. It doesn't mean that for every single database, we need to design every single database. That's not what it means. If I can remember well, you guys on GB1 learn how to create databases manually. And how? How do you do that? You use GBCA first, and at the end of the database creation on GBCA, you generated some scripts, okay? And those scripts were stored somewhere, right? You could use those scripts to create databases manually because you have scripts, right? Those scripts actually contain the structure of that database you just created. So you were able to use those scripts to create all multiple other databases, having the same structure, having the same data control file size, having the same log file size. So that script was actually working as a template for other databases. But the first one is maybe the one you took more time to design. Because multiple databases in the environment sometimes have the same structure, most of the time, okay, depending on the type of workload. So for instance, let's assume you have an application, and the application needs more databases to run. So meaning that if you want to create an additional database for that application, then you may have the same component as the previous databases. So you don't need to design it from scratch because you just want to add another database on top of what are already existing. So for that, you will just create a template and you can just use the template to create another database. But initially there was a design. A design is done by developers, analysts, okay? They will use some tools, having a lot of tools they use to create the logical part of the schema, to determine how the schema will communicate, how table will communicate, okay? How are they going to communicate with each other? Because don't forget, we are dealing with what we call Relational Database Management System, RDBMS. And when you guys understand the concept, when you guys, if you guys hear of, if somebody tells you, whenever you make mention of RDBMS, it means that tables are not tables are communicating, okay? Tables are sharing some common data. Let's assume you can have a column on one table that can also be found on another table because they can share some common data. Let's assume we are getting to a department, okay? A department like HR department, they may have some of your information, okay? Like your social security number, like your name, like your employee ID, all right? Even your salary. And when you go to the IT department, okay, they have their tables there. They may not have your social security number, okay, but they may have also your employee ID, your role, your name, and so on. Even if you go to the logistics or you go to other department, you can be found. Your information can be found on those departments, okay? So now, how will finance department know what is on the HR table? And how will HR will know what is on finance? Because those tables have some common information they are sharing. So that if you're on finance, the same information finance has, HR also has the same information. So that's a relational database. So tables are communicating, tables are connected, interconnected. So that is something that they build and they simulate to see. They also simulate the database growth. So they say, okay, the database now is 5 megabytes. How will be the database performance after when it grows to 10 gigabytes, 15 gigabytes? Did they just make some estimate to see, to try to simulate how the database can behave when it will grow in size? Okay, so that is something they do, the logic design part. Once now they do the logical design part, you now in the GBA, you come and create it physically. You can now, or they can also do that, okay? They can also do that. Now you can now come, okay, and now create the tables. you now create a table, you now create a schema, you now create, okay, the table with the constraint and so on. And also, during the design part, they pay attention to the data type. The data type of the column is very important. We have columns, okay? We have columns, employee name, first name, last name, social security, address, phone number, and so on. You guys saw multiple tables like that. Let's assume you have a table, a column called social security. And we all know that social security, all of them are numbers. I've never seen it, social security in USA with characters. Maybe in another state can be, okay, maybe in another country out in Europe, I don't know. But let's take the example of USA. Here, our social security numbers, I think it's 9 digits. And only numbers. Numbers, no character. So that means when they are designing, the data type of social security should be number. But we all know that you can still use VARCHAR too. VARCHAR, yes, we give you that option. You will not understand the impact of using VARCHAR. You will not understand the additional work you are giving to Oracle when you're using VARCHAR. It's more complicated for Oracle to scan the table when you're using VARCHAR than numbers, because VARCHAR takes multiple types of data, not just numbers, but also characters and so on. So for you to have a better experience, a better performance, if you know that the column will be using only numbers, then the data type should be numbers. That is something that they do at the design level. You will not understand it because you are dealing with small schema now, 107 rows, small. But you will get in an environment where the tables are millions of rows, millions of records. There, every single detail is important. So that's why at the level of design, they determine the right data type for the right column. They do that. At the level of the design, they determine the constraint. Are we creating primary keys on this column, unique keys, and so on? That is what they determine. Are we creating this table as a heap organized table or a cluster table? What is a heap organized table? That is the type of table you guys have been creating since you are in BronTech. We call that heap organized table. It's type of table such a way that whenever Oracle wants to add a row, Oracle will just try to look for any area and just add a row randomly on the table. Rows are not always organized, such a way that it always go from an ascending order or descending order. Oracle will just try to see where the new row can fit, and we just come and update. But you can also have other type of table, index organized table, cluster table, and so on. I will talk a little bit about index organized table, and I'll also talk about cluster table, okay, another day, because I have a PowerPoint on that. I have a slide on that. So those are stuff they have to consider whenever they are designing. At the level of the column, how unique do they want the data to be for an index? Let's take an example. If I'm creating a primary key, a column as a primary key column, it means that the record on that column are unique, because a primary key column, on a primary key column, right, rows are unique. The primary key is a unique identifier, right, of a row on a column. So meaning that if I say this column is a primary key column, it means that every single record on that column is different. All of them are different, and they are not null. So you cannot have a null record there. All of them are different. Like you guys, I can guarantee you guys that 2 people in this class will not have the same phone number, because your phone number is your unique identifier. Your student ID is your unique identifier. Here, your social security is your unique identifier. So that means if we have a table designed with all the students from BronTech there, I can guarantee that the primary key column can be your student ID. Okay, but now you will see that we talk about foreign key because since tables are communicating, okay, the primary key columns can be found in a different table. So that employee ID, right, can also be found on another table. And now it will not also be a primary key column there. We will call it a foreign key column. It will be foreign key because it's a primary key now residing on a different table. So foreign key and primary keys are the same. But the difference is that one is actually on one table as a primary key, but the same column on a different table is called foreign key. But now what happened is what? Oracle will automatically create an index on a primary key column, but you will not create an index on a foreign key column automatically. You guys should know these differences. So that is something they do, they design that way. How they want the relationship between tables, 1-1 or 1 mini and so on. That is done at the level of design. That's why if something is wrong at that level, your whole life you have performance issue because you cannot change it. That's how the final package is. You cannot change it unless now you can just grab the data that is there and build another database and dump the data there in the new database. But you cannot do anything on this existing database. It's lost. Okay. Question before I go to indexes.
Yes, I have a question. So you kept saying they on your previous slide. So what do you mean by they? Are you talking about like already existing tables that that are being created, or for instance, if I want to create a table, does that mean it's going to already come with the data type that I can use? Is that what you mean?
If in most of the time, okay, you won't just create a table like that. You will just receive the command from the developers because they already determine the raw data type for you. You just create it. You're not the one to figure out the data type you allocate. They already tested everything in a lower environment. They just give you the script to create it. Okay. You guys deploy PeopleSoft?
No.
You guys never run a script where you have to import some stuff on your database on TLS-DMO? Because what happened is what? The application connects to a database through a schema, through one or more schema. So meaning what? If I have an application, an HR application, meaning the application is used in the HR office, they are doing their job. That application is connected to my database through a schema. That is why you guys can see a schema in your database called HR, because the HR is the application schema. Okay, for you guys, just a demo. So every single application that connects to database connects through a schema, an application schema. Now, that application schema should be imported on your database because when you are creating your database, an empty database, it is not present. So sometimes you need to import the new application schema in your database for the application to be able to make the connection. Now, that schema is already designed by the application team. Maybe it is designed by the application team in your company, or maybe the provider already designed it for you. Let me take an example. We have two types of applications. We have custom applications and off-the-shelf application. A custom application is actually an application that is built by developers in the company. That means you have people who stay together and they build the application from scratch to do something. I want an application now to do this job for me. We build an application, okay? And that is custom. They build it. And that is, so when they are building it now, they go through the design before they build it physically, okay? And if it's off the shelf, it means that there is a vendor, somebody, they bought the application and maybe they customize it, but they bought it from someone else. Now, the schema is designed already. So the schema, on that application schema, they already created all the objects. All the objects are already there. Like on HR schema, when you go to HR schema, right, you already find employees table. You already find, I don't know, region. Already find countries. They are there. You never created them. Even though for the purpose of, practice, you guys can find it on GBCA. But in a real environment, whenever you are trying to deploy an application on the database, you need their schema in the database for you to be able to access the application object. So those tables that are present on that schema, tables, indexes, synonyms, all those objects were designed already by the application team. So now in few scenarios, you can find yourself adding new table or adding indexes. And if you have to do that, it should be tested before. It should also go to the development phase. On the development phase again, they will test it, they will try to see the performance impact of the change. And now they will give you the script most of the time, okay? Most of the time, they will test everything again. If they find the need to add a new column or they find the need to create an index and so on, they will develop it again, test it again, and they'll just send you a query. You just run a SQL statement on the production. Just copy and paste, and that's fine. You don't determine the column type.
So in other words, if you wanted to add a schema, that will be done at the development stage.
Yeah, you don't just object like that. Okay. They add it there, but before we add on the production, if they don't have the permission, they will give it to you and you run the script. So meaning you should not go in an environment because you think you are a GBA, you just issue create user. To create a user, you need the permission. To create a table, you need the permission, and everything you do. So if you have to create a table, somebody has to tell you to create a table. You don't just create it because you think it's good.
So,
Yeah.
take for example, what we have right now, like what we've been working with, we've been creating users and schemas and all that. So that means our databases right now, they're at the development level, not at the production level, right?
Why are you saying that, first of all? Why?
Because like we're able to create the schemas and everything.
No, it's just for you to have hands-on experience on how to create a schema. But it doesn't mean you will be creating schema frequently in an environment. It just understand. The next time a developer will come and give you a script to create a schema, you understand that command before you run it. The other thing is that you will not just create schema as you want, right? Yes, true. What you're saying is partially true, partially right, because for you can wake up in the morning, you just create a user as you want, right? And sometimes in your environment, the development database, the dev database is sometimes the playground where you can do your stuff. It's possible, yeah. I don't know if you are getting me.
Yes, I understand. So in this program, are we going to go through like the different things that happen in the life cycle, like the testing and the unit testing? Like I know that it's just unit testing, but I don't know what it really entails.
All this stuff are just validations.
I'm sorry?
All those stuff, okay? Yeah, about all those testing, just some level of validations, okay? You don't have an application. You guys don't have applications connected to your database. So there's some type of testing you cannot do at your level. See, you have an application connected. You guys are just dealing with empty databases. You guys are just dealing with databases without application connected to them. Do you have somebody connected to your application loading the database frequently? Do you have?
No.
You don't. So that there are some type of testing you will never do here. Because whenever you do a change in the database or you upgrade the database, the application team has to test it. They have to see if the response time that they were having before is the same response time. All those stuff, stress testing and so on. they do this. The application is the most important area on that scenario after a change is performed. But you cannot do it now because you don't have any application connected to your database now. Okay?
Okay, thank you.
Excuse me, please.
Yeah.
Okay, I'm just a little bit confused because I don't know. Is it the developer that would actually create the indexes or create a table, or is the DBA?
Most of the time, right? Most of the time, whenever there is a need for indexes and all those stuff, that they want to create it at a lower environment.
Okay, the DBA.
No, the developer.
Okay.
When they create all those objects, even the partitioning, all those stuff, when they do all that in the lower environment and the performance is as expected, they move it to the test. They perform all the testing, they move it to the pre-prod. And then if they have the permission in the production, they will do that. But if they don't, because most of the time they don't have permission on the production, you do. So they will give you the script and you just run the script to create it on the production. But actually, they already tested everything in the lower environment. Does it make sense?
Yes, thank you.
No problem.
Excuse me, sir.
Yeah.
Yeah. In fact, looking at what you have been teaching, I mean, not be able to gather everything. Are you going to have like a real life situation where you're going to demonstrate all what you have been teaching? Yeah, I mean like application.
What do you mean by application?
I mean, are you going to like come up with some exercises to really apply what you have been teaching with these indexes and so on?
That is part of presentations, okay? Whenever I'm talking about something, like I made mention of indexes, there's a group and indexes, and that is basically what is the activity. The group should show us how they create an index and how they can run a query with an index. We see the result, and without an index, we see the result.
Okay.
Yeah. Another question?
Oh, a question, please. So if I understood like what my colleague just asked, so it's still gonna be the same thing like with the AWR report, what like the group handling it is gonna demonstrate everything about that, right? Like how to run it and how to read the report.
Sure. That's why I made mention of that, right? On the note at the end. If it's just theory, it doesn't change anything. Okay? So again, as I said, I usually perform all of that myself, but it was taking 8 weeks, 6 weeks, 7 weeks, 8 weeks. Why? Because I have to do that myself, all of that, and I have to explain every single scenario. And by doing that, of course, I should expect questions from you. People were asking questions, and performance tuning itself alone was going to 8 weeks. What about other projects? So now, I'm not meaning that I'm just removing the load from I'm just now giving the responsibility to a group of people. They take it seriously. I explain the concept here. What they need to do is they have a platform, they have a server. Whatever they will research on, they try to implement that. By the way, one of the best presentations I ever had was with the previous class, because every single topic we had demo associated. That is what we need. If you have AWR, you have to show us how to create an AWR report live in front of us. You have to tell us the important areas of that AWR report. If I give you SQL Tuning Advisor, how can we call the SQL Tuning Advisor? That is what we need. We need to see how it works. We want you to simulate it, to give us the, like I provided some demo, right? That is what we need. So that it make more sense. We don't just see the theoretical part, but also after your presentation, we can also go home and try to do the same thing. That is what presentations are, not just command.
So if I understood you, it means you shared it to various groups already. So after we have done everything. So like, for example, group A, group B, group C. So if, for example, I belong to group A And what you give to group B, like after they have presented it, I might still like go back to like try to see if I can also put that in effect, right?
Correct. Yes, that's why there's a lot of knowledge. You share a lot of knowledge during that session. A lot of knowledge. Because of course you will not just focus on your area, but also you also try to understand other people topics. Let's actually have a group with Ronaldo and all those other people. This is a group. They will come and they will present AWR, show us how to generate an AWR report. ADDM, how to create ADDM, ASH, how to do that. And the report, explain plan, how to do that. They will bring up the theoretical part. We don't need a big PowerPoint for theory, no. We just need to understand what they mean. And now they will come up with the server. They log into the server, they create each of these right in front of us. And we read that together. If they don't understand some areas, we try to explain. Now, once they are done, it doesn't mean they should, and once they are done, they will just forget everything. No, they will wait for other group. The other group will present the same day. Because they were more focused on these topics, they also try to understand these other topics. That is the same thing for everybody. So if you attend all these sessions, then it will help you to understand the theoretical part and the practical part of all those topics listed here. You covered everything. You covered everything. That is why presentations are the critical part of this. That's why I gave you guys this presentation ahead of the time, so that you not complain, so that you have enough time in your group to start working on those presentations from now. You have 2 weeks from now. So you don't have, you should not expect, I should not expect complaints that you do not have enough time. You can meet with your group at least 1, 2, or 3 times before the day of the presentation. So that is why you have it ahead of the time to make short PowerPoint, but to implement, to do demo, live demonstration in front of us. Does it make sense?
All right.
Yes, sir. It does.
All right. So I'm just helping groups, okay, by bringing the concept so that when they are doing their PowerPoint, it won't be too complicated. Otherwise, I could just say one word and I move to the next PowerPoint. So, going to indexes, okay. An index basically is a database object, okay? And the index actually helps it helps to speed up data access. To speed up your query, okay? So it's an option that Oracle provides. So it basically works as a book. If you have a small book of 20 pages, you can, if you are looking for one of the pages of that book, you can just go one page after another till you find it. You can find the page you are looking for within the next 20 seconds or 10 seconds, because you are not dealing with a lot of pages. But if you are dealing with a book of 300 pages and you're looking for a particular page, you going over every single page can take more time to find the one you're looking for, to identify the page you're looking for. So that is why on those big books, when you go behind, somewhere at the back, you will find a table of content, an index that can tell you where you can find these topics and so on. This helps you to easily get to where you are looking for, to easily get to the page you are looking for. So that is what an index actually does in the database as well. For big tables, the index helps you to access the data faster than if you were going to the table directly. So meaning now that in case an index has to be used, you have two options. If an index has to be used, that means what? When you are coming to the database, when you are coming to the share pool, the optimizer may decide to use the index or not use an index. The optimizer will basically choose the cheapest option. If the index is the cheapest option, the optimizer will choose it. If the index is more expensive than to go to the table directly, the optimizer may not choose the index. So in a scenario, if the index is chosen, then you have two scenarios. Either your query, the server process will go to the index, then go to the table, or you will just go to the index and return the result to you. So the server process may go to the index. Then the index will give that server process the information it's looking for to go to the table, and from the table, it can retrieve the result and send it to the user. Or the server process can just go to the index and just find the data right from there and just return it to the user straight without having to go to the table. Okay, now I will go a bit deeper on this scenario if an index is used. So why? Because an index can be created on one or more columns. So when you have a table with multiple columns, an index can be created on one of them or multiple columns. If an index, the regular index is created on one column, but if you want to create an index on multiple columns, we call it a composite index. This is an example of a composite index. So if I want to create an index, name employees, EX, and I want to create it on table employees, table employees has multiple columns, but I want the index to be created on these three columns. If I want it to be created only on one column, I will just specify one column here. Okay, so depending on how many columns you want to be created. So with this one, whenever a user issues a query and the optimizer decides to use the index, the server process will go to the index table first. Now, if the person who is trying to query, because this index will store all the values of each of these columns. So that means if on your query, for instance, all right, so let's take this example, this same example. Okay, we are having, I have two queries. The first query, all these columns are indexed. Okay, no, let me not take this one. Let me take job ID, because whenever you specify on the where clause, when you use the job ID, then the index will be used. So let me take job ID. If I don't specify if the column I specify after the where clause is not indexed, then the index will not be used. So I assume that this column is indexed. Why? Because on here I can see that the index called employees underscore IX is created on all these columns. Okay, so it means that and someone runs this query. Okay, once you run this query, because all these columns are indexed, then you can have the result of your query right from the index. Does it make sense? Yes or no?
Yes, it makes sense.
Because each of these columns are indexed, each of them, last name, job ID, salary, all of them are part of the index. So meaning that if you go to the index, okay, you can get all those information. So meaning after the server process goes to the index, you won't need to go to the table again, because you can find everything from the index since all the columns you're looking for are indexed. Okay, when I will explain the access part, I will call this one fast full index scan. But now, this second option, we know that the first name is not indexed, but job ID is indexed. It means that job ID is specified in the workloads. Yes, the index will be used, but the server process may need to come back to the table to get the first name that matches this condition. Does it make sense?
Yes, sir.
Yes.
Explain that again, please.
In this first example, we understood that when the server process will get to the index, it won't need to go to the table again, because all the columns you are looking for in the select clause, all of them are indexed as per this query. The index is created on last name, job ID, salary. So if you are querying for last name, job ID, salary, or any of them, okay, then the result, you can get the result straight from the index. You don't need to go to the table, because, okay, you need the index to be used. But with this second option, there's a column that is non-indexed. So meaning you can't find the result of first name in the index, because this column first name is not an index column. These are the 3 index columns. So what you can get from the index is the job ID. So you have now a 3-way relationship. So mean the server process may need to go to the index first to get, to identify the matching rows from job ID, and then it can come back to the table in order to get the first name, because the first name is not in the index.
Okay, I understand.
Quick question.
Yeah.
Who creates the index? Who specified that some specific columns are indexes? You specify it when creating the table, or some tables come already telling you which columns are indexed?
Once the developer is writing a query, okay, it's advisable to use highly selective column on the workloads. And highly selective column are most of the time the index column. So you will not just specify any random column here. If I come, instead of job ID, I specify first name equal, an index won't be used in this scenario. So it's advisable to be using highly selective column or index column whenever you are trying to query some data. Or if somebody is issuing, or you notice that the user is not aware of the index that's existing, okay? And you, the DBA, you notice that the user is frequently querying the job ID column, then this column is a good candidate for an index to be created. I need to make sense what I just said.
Yeah, so the DBA is the one who, how do I put it? The DBA is the one who decides which columns are indexed.
If you notice on your end that users as well are frequently accessing that column, are frequently accessing the column called job ID. And job ID is not indexed yet. You can raise the request. You can find the need to create an index on that column. You won't create it because it has to go to development testing, all those stuff.
Okay.
But you will find the need for it to be created because you see that if an index is created on that column, the result can be, the user can have a faster result, a faster response time. But you won't create it, but you see the need for it to be created. In some environment, okay, there are exceptions. You can create it in some environment, especially small environments. So I'm not telling you that what I'm saying is 100% what will happen in all environments. You can get into an environment when they give you the total control of everything. So they can say that, okay, since you are the expert, okay, you yourself go to the lower environment, test that index, and come and run it on the production. Does it make sense?
Yes, sir.
Yeah. We're gonna have to be prepared on both scenarios. But everything has to be tested first before implement on the production. Everything.
I have a question. So in this example, are we talking about one index or multiple indexes? And also, can the table have more than one indexes?
Sure, yeah.
Okay, so in this case, are we talking about one index or 3 different indexes?
In this case, we are talking about one index, okay? One index.
Okay.
The index is a composite index. So if I even specify and salary equal 1,000, the same index will be used because the index is created on both salary and job ID. Only one index will be used, right?
Mm-hmm.
But if I had a second index created on a different column and I specify it on the workloads, then multiple indexes can be used.
Okay. And would I use more resources if you're using 2 different indexes or?
Sometimes it depends, okay? If the optimizer notices that by using multiple indexes, it'll be more expensive than going straight to the table and doing a full table scan of the table, then the optimizer will choose the table scan. So everything is done by the optimizer, the program that's going to assess the cost of each of the parts, each option. Okay? So the optimizer will never allow the server process to choose the most expensive, okay, access path. No. The optimizer will try to assess everything. Take all the options, all the possible options. Do you have a materialized view there? Do you have, can we use these indexes? Can we do this? Can we join? And all those stuff. And we try to pick the cheapest option. And that is what your queries we use. Okay, so about the optimizer, okay? That is even the PowerPoint right below. I will talk about how it works. Can I take some common example, daily part of your daily activities, and I will explain how the optimizer will deal with such scenarios. So I just wanted you to, now, let me explain to you how the index works, okay? Because maybe we are still getting it, but not exactly how it actually structured. And I want to explain it. Because I don't want to write everything from scratch, let me pick what I used with okay.
That's a quick question.
Yes.
So in relation to the cache result and the index, does the optimizer also choose the cheapest way as to if the information is in the cache result and index? Do it choose the cheapest part, or does the cache result take precedence over the index? How do that work?
The what? The chat result?
Yeah, the cache result and the index. If the results are in both places, does the optimizer also apply the same principle as to the cheapest way to retrieve the information?
What are you calling chat result, please? Maybe I'm not getting exactly what you are saying by chat result.
The cache result.
Oh, cache.
Yes.
Oh, okay.
So I was comparing it with the index. If the information is in both places, does the optimizer apply the same principle as the least resource use to retrieve the information from either the cache result or the index, or one take precedent over the other one.
Okay, okay. Once your query is even coming to the share pool, if the result is already in the result cache, that's the cheapest option.
Okay.
That's the cheapest option ever. So if the result is already in the result cache that is located in the share pool, immediately there's no parsing needed. The optimizer doesn't need to bother again to check, okay, to do soft parsing or hard parsing. That result will be returned to the user. That's the fastest option and the cheapest option. It's already there. Nothing to do. Just get it and send it to the user. Maybe the cost is just for you to find it. The result is also managed by like the least recently used algorithm. So old result will be flushed out. If that result is still there, then the optimizer will just send it to the user, the end user. But if it's not there, then that is where you will have those hard parsing, soft parsing, and that is where the optimizer now will try to identify whether we need an index or we don't need an index and so on. But the first option is the result cache, and the other option follow.
Okay, thank you.
No problem. So let me tell you an example of how a query works in an index, how indexes work. So let's assume I'm having a query like this. And we have an index created on employee ID column. I told you guys that whenever you use, after the where close, you use the index column, the optimizer will take the index as an option. So the optimizer will try to see whether it can use the index or not. But when you don't even specify it, the index will never be used. So if you come and specify a column here that is not indexed, we will never use an index on that table. So that is why let's assume that an index called IDX has been created on this column called employee ID. And you, the user, you issue this command. Let's assume that the optimizer and the table has 1,000 rows. And you're looking for employee ID 103. Now, let's assume the optimizer decided to use the index. So because only employee ID column is indexed, the server process will go to the index, then come back to the table in order to get the first name and the social security, right? Because the value of first name and social security are not found in the index. Does it make sense what I just said?
All right.
Okay.
Yes.
How does it work? So how does it work basically? We all should know that in Oracle, every single row in Oracle has a unique identifier called row ID. Every single row in Oracle on a table has a unique identifier called row ID. That is a hidden column. You cannot see that when you issue select star. If you specify select, you specify select. Let me see. How am I doing this? If you specify this on a column, you guys can try that. You will see that there's a new value that will be returned to you. Okay? But if you don't specify, Oracle will never return it to you. So every single row in Oracle has a unique identifier called row ID. Now, why is the index used? when you issue this command, Oracle will do what? The server process will go to the index and try to look for the value employee ID equal 103 and identify the matching row IDs and try to identify the matching row IDs. And now, once I identify the matching row IDs, the server process now will come back to the table and identify those rows with those IDs. Are we getting what I just said?
Yes.
Okay.
Can you repeat that, please?
Yes, let me go back. I was saying, you are issuing a query like this, and employee ID column is indexed. And let's assume the optimizer try to check all the options, because I will explain how the optimizer thinks in a moment. Let's assume that the optimizer try to access all the possible options for your query, and the optimizer decided to use the index called IDX. It means that your server process may need to go to the index table first, then goes to the table itself. Why? Because the index doesn't contain first name and social security values. So now, once the server process will go to the index, it will try to find in the index, okay, the value 103. And once you find the value 103, you will try to identify the row ID of 103. All the matching row IDs of 103. Once you can identify those matching row IDs, because every single row has a unique identifier. Once you can find row ID, the matching row ID, you can easily detect it as well on the table. You will be able to detect that row ID faster on the table. Let me explain how you will go. So it means, for instance, I said our table has 1,000 rows. And an index organized this way. We have a root, we have branches, we can have one or more branches. And you have the leaves, that's the last level. An index is organized in an ascending order by default. Ascending means from the lowest to the highest value. You can see here that it goes this way. Ascending order. So that is why the index is organized this way, the B3 index. So when you issue your command, select whatever where employee ID equal 10. I mentioned 103, right? 103. The first level of an index is the root. On the root, we splitted those 1,000 rows into blocks. So the first block may take values from 0 to 50. The other root may take values from 51 to 200. The third can take from 201 to 500, and so on. Does it make sense? So we split it into smaller chunks of, into smaller pieces, such a way that if your query is, if the server process is coming, the server process will just check among all those pieces where the matching values is found. For instance, this block takes from 0 to 50. This one is this value you guys see here are the first values, but in between you have range of values. So this first root, right, we take everything going from 0 and till the value before 51. That means this root we take from 0 to 50. This other root we take everything from 51 to any value between 201, right? So we assume anything between 51 and 200. Does it make sense? And on 201, we take everything from 201 till more probably it can be 400. okay? I don't care about whatever happened before. But now, if I'm looking for 103, which route among these three can be chosen? Will be chosen.
50, 0, is it?
Go to 60.
51 to 200.
From this one takes value from 0 to 50. This one takes value from 51 to 200. This one takes value from 201 and above.
51 to 200.
So meaning the value I'm looking for is here. So the server processor will not waste his time to check any of these branches, anything that is under this route, right? The server processor doesn't care about any of these. We just focus now on one. Now, is we go at the more granular level. I said that this one is a route that goes from 51 to 200. Now, this route in the index again is split into smaller chunks. Again, the other chunks now can now go from 51 to what?
100.
To 100. This one can go from 101 to what?
151.
No.
150.
150. And this one will go from 151 to what?
200.
200, right? So it's going more granular. It's more granular. Now, between these three, where can I find 103?
101 to 150.
101.
On this branch, right?
101, yes.
This branch. So you can see that we are eliminating this branch and this and so on. And once it gets to the last level, that's the leaf. We can have multiple branches depending on the index size. If the index is bigger, we can have another branch and the same procedure, okay? We work the same way. But we have only one leaf, last level. On the leaf now, we have the value we are looking for on one column and the unique identifier or the row ID on another column. For instance, what are we looking for? Which value are we looking for?
103.
103.
Employee ID equal 103. We can find 103 here, right? Now, the unique identifier of the row that has employee ID equal 103 is here. That's the row ID. You don't need to understand the language. This is what we call row ID. Now, what happened is what? The server process now, when it is going to the table, it will no longer go and check 103 because it's more difficult. It will now go and check this ID because every single row on a table have a unique identifier called row ID. So it'll be faster for the server process to enter the table header and go and find this row ID. Does it make sense?
Yep.
So once you find the row ID now, everything that is on that row, you can now get the value of everything on that row. That is how a server process goes to the index, then can go back to the table. Because the index do not have, the index doesn't have other values, other first name or last name or social security. If that index was having if that index contained first name and social security, okay, the server process will not need, okay, won't need to go to the table again. But if the server process is going back to the table, it is because that index can store only employee IDs. So the only thing the server process needs from that index is just the row ID, and it can go back to the table and return the result based on the row ID was able to retrieve from the index. Does it make sense?
Yep. Please I have a question.
Sure, please. Go ahead.
Okay, on the previous note, the previous page here. Yeah, I'm seeing like you upgrading the index. Could you throw more light on it?
What?
Like upgrading the index.
Where do you see upgrade, please?
Hold up. It's like I saw something like upgrade. Hold up.
Update?
Okay, update. Sorry, I'm sorry.
Okay. Yeah. Okay. I was just explaining how a default B2 index works. Jump into more detail on this before we go on break. Okay. So
okay.
an index can be Pay attention to this. Usable, unusable, visible, invisible. This you can have two options working together. So that means we can have an index that is both usable and visible. That is the default option you guys have. Whenever you guys create an index, you guys can see that, right? The optimizer can see that by default. Okay? Yep. If I issue this command, by default, the optimizer, while the optimizer is trying to make his decision, the optimizer will consider this index. So it's visible to the optimizer. And by default, it will become it is usable. So that means the optimizer can use it. Does it make sense? To create the execution plan for your query. That's why you guys can see that the usable and the visible options are the default, because that is by default, all the indexes are usable and visible. Okay? Now, an index can become unusable for any reason. Whenever an index is unusable, it can be unusable and visible. Means what? The optimizer can see that, but the optimizer is not using that to make a decision. I know you guys can see the difference. Yep. So I can see you. I know you are there. I know an index has been created on this table. I know that, but I'm not using it. I'm not using you because you are not a good option for me. It can become unusable because maybe the optimizer finds the index to be more expensive. The optimizer finds the option of using an index being more expensive than going to another index or a table. Alright. So if I see that the cost of using this index, okay, is more than the cost of going straight to the table, how will I use that index? I will not use it, right? I'll just go to the table straight. Yeah. So that index now will become unusable. It is visible, but it's unusable. It is there. And sometimes an unusable index, it is not updated by Oracle. Once an index becomes unusable, most of the time it can come with statistics. Maybe statistics are not up to date. And the index is not aware of a lot of information. Let's assume that statistics were gathered last night. But today, today, statistics should be gathered. I think I asked this question right after we come back. So, statistics were gathered yesterday. So that means that index was updated while the statistics were gathered. But some rows were added on the table, multiple rows. The table was 100 rows yesterday. But today, the table side, we have now 150 rows on the table. But the index is supposed to be updated as well. Whenever you're adding a row or you're updating a row on the table, the index should also get updated. Now the index is not updated. Okay? So whenever the index is not updated, maybe because of those statistic stuff, it becomes unusable. It means that whenever you are doing a change on the table, the index is not getting updated. The index is not aware of that. It becomes unusable. An index can also become unusable. That is another scenario of an index becoming unusable. An index can also become usable because of the scenario I explained earlier. Why is that? Why is the optimizer not using the index? Maybe because it's expensive, as I said, right? Why is it expensive? Maybe the index is also too big, very big, bigger as well. Because as the table grows, I told you guys that as the table grows, the index will be updated. Whenever you're issuing a GML, you're updating a row, you are deleting, you are inserting, or whatever GML you're issuing, right? Oracle should update the index accordingly, right? So it means that the index should be maintained by Oracle. The index should get those up-to-date information. So as the table is growing, the index should be growing as well. And at some point, if the index has grown too much in size, the cost of scanning that index is also more complicated. Let's assume that on whatever I explained here, we had more branches here. More branches. It's also difficult for me. just at the index level, it's also difficult to get to the data. So I will struggle at the index level to get the data, and then I will have again to go to the table to get the row ID. But the optimizer can judge either, okay, can decide not to use that index because the index has grown too much in size, and the cost of scanning that index is more expensive than if the optimizer, the server process just takes its time and goes to the table directly. In that scenario, that index is unusable because it's not helpful for the optimizer. And once Oracle notices that an index is unusable, it stops updating that index. And it's very simple for you. Most of the time, your performance issues can be at this level. Most of the time, whenever a SQL statement is running slow, sometimes you will notice that an index is not used. It is there, but it's not used. And it's very easy for you to make it being used, okay? You can just do what you call reboot the index. You can just reboot the index. So you just issue a simple query like alter index, you put the index name, reboot. On 12c, you can do the reboot online. You can reboot or you can reboot online. So that means when you are rebuilding, normally when you are rebuilding, the table should go offline. That means the table may not be used by the user. But once you do online, it means that while you are rebuilding the index, users can still access the table and do whatever they are doing. This is the simple command you issue. You will not just do like that because you are guessing, okay? You will make some diagnostic, and a guy comes SQL Training Advisor can tell you to do this. You just run the command. This one, you don't need any testing to do that. Once you perform your, okay, you do your investigations, and you call, for instance, a guy like SQL Training Advisor, he will tell you sometime that an index is not used. By rebuilding the index can improve the performance. So by just issuing a command like this, it can help the index, it can refresh the index such a way that the index can now be used by the optimizer. And that's it. So an unusable means it is not, it's there, it can be visible, but it is not used by the optimizer. Unlike unusable, we have invisible. Invisible means you are making it manually invisible to the optimizer. So you don't want the optimizer to consider that index while making his decision. Unlike unusable, the optimizer was the one to decide not to use it, right? Because it was not helpful. But invisible, you do it manually. Alter index, index name, invisible. So it's very easy for you to put something invisible. Just put invisible. That's it. Once you make the index invisible, it means the optimizer, right? Once it gets to that table to get information, it will not even see that index for you. It will not see. The index is there. Instead of you dropping that index, you can make it invisible. Because if you drop an index and you see that you can still use that index in the future, you have to create it again. But by making it invisible, the optimizer will not see the index. So the optimizer will not consider the index while making his decision, because it's not even seeing that. And later on in the future, when you find the use of the index again, you can bring it back to be visible. And the optimizer now can use it. Are we getting the difference between all these four?
Yeah, a little bit.
Okay, where are we confused? Just let me know. Okay, so maybe by reading again at home, you will later you will understand. You have the whole weekend. You will come back Monday, question I will answer. So we all should know that the index doesn't affect the table. If I drop an index or I create an index, the data on the table is not affected. You are just creating an index because you want to speed up data access. It doesn't mean that if I drop an index, I will lose the data. No, the table will still stay as it is. Nothing. Does it make sense? But by dropping a table, you can also decide to drop an index. If you want to drop the table along with the dependencies, you can do that. But by dropping an index, you will never affect the table data. And again, Oracle automatically update indexes. That's why indexes are quite expensive. Because Oracle, whenever you issue a GML, Oracle will automatically refresh the index, right? If I insert a new row, I want the index to be aware of the new record I just inserted. So Oracle should refresh that index, and it can cause performance overhead. That is why indexes are best for select statement. Because whenever you're issuing a select statement, you are not changing anything. You are not adding the data. You are not removing the data, okay? You are just querying. A SQL, a select statement is a data query language, right? So you are just querying. But whenever you are issuing a GML, you are changing the data. Either you are adding, you are deleting, you are inserting, and so on. So that is why an index should be updated by Oracle. And it is another job that needs some resources. We should know that an invisible index is invisible to the optimizer, but is still updated by Oracle in the background. So meaning that if you make an index invisible and you insert a new record on that table, the index will be updated accordingly. So it is there, it is getting updated by Oracle, but an unusable index is not getting updated. It's there, you add a new row, you remove, it's not receiving it because it became unusable. It is there, but it's not useful. And on 19C and above, Oracle will ease the job for the GBA by automatically creating indexes for you when needed, managing those indexes, making them invisible when needed, deleting those indexes when needed, rebuilding with indexes when needed. It's automated for you on 19C. So you have to be on 19C to take advantage of this feature, automatic indexing, okay?
Okay.
These are the type of indexes, okay? We have B-tree, bitmap, function-based. B-tree is what I just explained, is mostly used on highly selective column. That means column with less duplicate values, like phone number, social security, okay? Column where you don't have a lot of duplicate. You have more unique values than duplicate values, okay? So that's why it's mostly used in OLTP environment, online transaction processing. And bitmap indexes are other type of indexes used in low selectivity columns, like column with low selectivity, like age, gender. Your gender, you can be a male or a female, okay? Or if you have a Boolean, you can be yes or no, or it can be, okay? All those stuff. So wherever you can have a lot of duplicate values, then bitmap are mostly used, okay? Because those values I just listed are not unique. If I have a table of 100 employees, I'm guaranteed that I will have a huge number of male and a huge number of female, or more male than female, but I will have a lot of duplicate values than if I'm creating a column called employee number. It will be different. So that's why bitmap are mostly used for those type of column with duplicate values. And also you have function-based indexes. A function-based index is basically an index that stores the result of a function. You can decide that on the index, when you are creating an index, okay? This is an example of how to create an index, a function-based index. So you are saying that maybe the index will store the result of a function. Let's assume that you want to create a column, okay? So you have a column, you want to create a column on the table, and that column is maybe the employee salary plus the bonus. and you created a formula for the bonus. Maybe you say that, okay, you have a bonus every year. So meaning that that column is maybe the addition of your initial salary plus the bonus. And you create a function, a function that will make the sum of the salary plus the bonus, and we put the value on a particular column. Okay, so that column now, you can decide that you want to index that. That's an example of, okay, a column that can be the result of a calculation. Okay, so now the index, now you are saying now that instead of having a separate column where you can have the sum of the salary plus bonus, you want the result of that calculation to be stored in an index directly. Or maybe on this example, as you can see here, you want the first name of all the employees to be in capital letter, okay, in the index table. So I know that I can enter your record on the table by putting maybe the first character in capital letter and the remaining one in lowercase. But I want everything to be in capital letter. So if I create a function, if I use a function, this is an inbuilt function in Oracle. Oracle provides this function, uppercase. So by having this function, by using this function, upper, first name, it means that on the index, I will find the first names in uppercase. So everything that's in the index will be in uppercase. So meaning whenever somebody is using a select statement and the person wants the result to be returned in uppercase, the function-based index will be used. And that is better for performance instead of using a regular index. Let's assume that I created a regular index without using the upper function. And you, the user, you specify upper. That means you want the result in uppercase. It will work, but you may not use your regular index because your regular index is not a function-based index. Okay? We also have index organized table. I just told you guys that if all the columns were found on the index, you won't need to go back to the table to retrieve the data because all the columns can be found there. So once you get the information from the index, you can just return it to the user. That is an index organized table. It is a table organized as an index. It's a table organized as an index. These are the possible options why to use it. So with the index organized table, the table is organized as a form of index. So it's organized in order, either ascending or descending. So you having that, you don't need to go back to to a table again to retrieve some data. No, you can get everything from the index organized table. But a very good condition is that you should have a primary key defined on that table. So unlike heap organized table, index organized table are organized as indexes. So if you understand how an index works, that is how an index organized table also works. So meaning now, we don't have only one column on this index, we have now multiple columns on the index. So that means the table is organized as a form of an index. Any question? We go on break. Okay. I know for some people it's confusing. But maybe after the break you can have questions. Okay. Okay, let's go on break. And when we come back from the break, I'll talk about partitioning, introduce partitioning, because again, there's a group to present it. And also I will talk about optimizer. We have to stop at 22 today, 23. That's where I stopped the morning. Today I started earlier in the morning because I had a meeting in between. So that's why I'm spending also more time with you. Okay. Okay, guys, let's grab a glass of water and we meet later, okay?
Okay.
Thanks.
Like what time?
What time?
Oh, sorry, 15 minutes. 15 minutes. Not. Let's take. What time is it now? 8:24.
8:24.
8:40. The group assigned to do partitioning should also, show us how to create each of these partitions and create them in front of us. Okay. Show us how to monitor partitions. Partitioning is basically helps the user to the GBA to, or the developer, the person who is doing the job, right, to split a big table into smaller pieces. Okay, so you have a table that is very big. Despite the fact that you have indexes in that table, you may still have performance issues. Okay, because the index is not always enough. And then I told you guys that whenever you have to perform a GML on an index, the index has to be updated by Oracle. It means that if the index is bigger, then the time you take to update that index, okay, you also take more time for Oracle to update that index, and you also take more resources for Oracle to update that index. So it's an expensive operation whenever you are performing a GML on a table with indexes, okay? So, and partitioning, it will help you to split that table into smaller pieces. It's mostly performing, for big tables, data warehouses, most of those tables are partitioned. Tables, okay, with sizes ranging in gigabyte, 2 gigabyte and above. And they are good for GML and also select, okay? So you can have, it doesn't mean that whenever you have partitioning, you should not have indexes and vice versa. It means that both can be used together. So I mean, you can have a big table that is partitioned and an index is either created on each of the partition or for all the partitions. So I mean, you can still implement an index, you can still implement indexing techniques on partition, okay, on partition tables. So it's still possible to put both together. It's even a better option, because you can partition a table of 1 million records. If you split it into 4 species, okay, it can give 250,000 records per pieces. It's still a lot. So those 250,000, okay, on that partition that has maybe 250,000 rows, you can still partition it again, or you can still create an index on those partitions. So it means that partitioning and index can still work together. And when you decide to create an index on a specific partition, we call that type of index local index, because that index you are creating now, it is dedicated to a particular partition. So other partition will not use that index. Only that partition will use it. And if you want an index to be used by all the partitions, we call it a global index, because whenever you use that index, it can help you it can redirect your query to a particular partition. And we have new partitions are coming, okay, back and forth. I have partitioning on 18C. I think there's a new partition technique. I did not mention it here. But even on 18C, we still use interval and all this stuff. It depends on the table structure and what you want. That is why before we partition, we have to do all this stuff happen at the development level. We have to know the partition key. The partition key is actually the column you want to use to partition the table. So you have a table. Do you want to use you want to partition based on the column, based on the state, or you want, if I have a column, for instance, state. Let me have a table, right? I have a column employee ID. I have salary. I have state. And state, you can have people who are living in California, people in Virginia, people living in New Jersey, and so on. All the states you guys know. So let's assume that I can pick 3 states. Let's pick Maryland, Texas, and California. So it means that everybody, all the users on that table either belong to Maryland, California, or Texas. They live in either of those states, okay? Now I can decide to partition by list. So meaning I'm partitioning based on a list of options. So on that column, it's a list. I have 3 options. Either you will be on either on Maryland or California or Texas. So meaning I can create a partition for all the users residing in Maryland. I can create another partition for all the users residing in California, and also I can create another partition for all the users residing in Texas. So you are partitioning based on the list of values. You have a list. So that means the column state is like a list of options. So the column state is like the partition key. That is what you will use to partition that big table. Okay? So the big table is still there, but we have now partition. So the next time somebody is querying the table, if somebody is issuing a query and the person is looking for record of employees living somewhere in Texas, automatically the optimizer is going to redirect the server process on that partition only. You don't need to go to the entire table. You can be redirected to the partition directly or to the index of that partition. Okay, so that is basically how list partitioning works. And another benefit of partitioning is that you can store the partition on different table spaces. So meaning it's not mandatory for all of them to be on one table space. You can have one partition in table space 1, another partition in table space 2. It means that if I'm doing any maintenance on this particular table space, other partition will not be affected. So it gives that high availability option. So list partitioning, it means you have a list of options. It can be state, it can be region, or whatever is listed. Okay, it can be gender and so on. You just determine what possible option and you create partition based on those options. And range partitioning, it can go with a range of values. That's why it mostly goes with a range of value like time, or maybe the range of ages. Let's assume when it comes to time, let's assume I have a column called date. And the date is the hiring date, hiring date, okay? When you got hired in the company. So let me take it from 1990. So I can have, people who came in 1990 who have been working since 1990, as you guys will see in companies. People who have been working since 1995 in that company. People who have been working since 2000. People who have been working since 2010. People who have been working since 2015 and so on. So those are multiple values, multiple records. So what you can do is you can partition based on a range of values. You can say, okay, all the employees who have been hired from 1990 to 2000, okay? We go on one part. Okay, I started with 1980. So people from 1980 to 1990 on one partition. That's the range of value. So everybody that falls within that interval, we go in that partition. Another partition from 1990 to maybe 2000 or I don't know, it's up to you, okay? Up to how the table wants to be partitioned. Another from 1990 maybe to 1995, another partition. Maybe another one now from 1996 to 2010, okay, another partition. So you are partitioning now based on range of values, and it mostly goes with dates, okay? And another one is hash partitioning, okay? Hash partitioning, all these options I just listed, right? Those partitions can or cannot have the same size. or they may not have the same size, because I may not have, if I'm coming to the list, I may have people who are living more in Maryland than in California or Texas. Does it make sense? So it means that you should not expect the partition size to be that to be equal. One partition can be more bigger than another partition. Same thing for range. I can have people who have been there more from 2010 to 2020 than before. So even in range partitioning, the partition size can be different. Okay, it can be different. But hash partitioning, all of them have the same size, and you don't determine how you want to organize the data. Oracle is the one to do that for you. The only thing you have to do is to specify the column you want to use as a partition key. Do you want to partition based on the first name, or based on the date, or based on the salary, or based on what? Once you identify the partition key, now you determine the number of partitions you want. Do you want 3 partitions? Do you want 4 partitions? Do you want 5 partitions? Once you determine those 2 informations, Oracle will automatically use an algorithm. That is an inbuilt algorithm, a hash algorithm. And automatically Oracle will partition the table for you and will allocate the same amount of record to all the partitions. So all the partitions will have the same size when you are doing the partitioning. All of them will have the same size. So if I have 100 records and I have 4 partitions, each partition will have 25, 25, 25, 25. Equal number of records. Because Oracle will do that automatically for you. Interval partitioning is an enhancement of range partitioning. With range partitioning, I gave you an example of hiring date. Okay, let's assume that we were in 2019 and we decided to implement partitioning, and we decided to use the hire date column. So since we are in 2019, let's assume that we created our partitions up to 2019. So meaning the last partition stopped at 2019. Maybe I did not create a partition for 2020. With range partitioning, if we get to 2020 and we want to add an employee on 2020, you will not have a partition for that employee because all the partitions stop at 2019. So Oracle will not do that. Will not automatically create a partition for you. You will have to create a brand new partition and add, so that you can add a record, right? Because the existing partition cannot support 2020 because when you were creating them, you range the values from whatever to 2019. But the new employee is coming in on 2020. So you have to create a partition manually when it comes to range partitioning. But interval partitioning, automatically Oracle will create the additional partition for you. So once you create it and you create a table or you alter a table and you partition it as interval, automatically when you are adding a new record that doesn't fall within the existing partition, automatically Oracle will create a brand new partition for that record. And that is how it works. So that is why this is a big enhancement of, this is a big feature that came on 11G release 2. It helped GBA a lot because you don't always have to be creating new partitions back and forth. With this list and interval partition, automatically Oracle will scale up the partitions. You automatically add partitions whenever new records are coming. You don't need to do anything. So this is 11G release 2 onward. And composite partitioning just means you have more than one partition method. It means that maybe you initially partition based on, it's a mixture of one or more partition method. Basically, that's what it means. So maybe you use list, partition, and range, list and hash, and so on. So it means that maybe initially you partition, you use list partitioning. And when you use list partitioning, it helps you to create partition, okay? And those partitions, you partition them again. So it's like partitioning under partitioning. And all these techniques are accessed ahead of the time. The developer, that is what they will do. They will try to check which one is the best for that particular table, which one is the most efficient for that particular table. And when they will come up with a big script, they will just give you the big script, you just run it on the production. But please, in case you are exposed to such scenario, always check if the script has been tested, because whenever they are submitting a ticket to you, it's a manual ticket. Because they are doing it manually, you have to check whether his manager or her manager approve that. Once it's approved and you have the result of the test attached to the ticket he's assigning to you, then you can go ahead and run. But if you don't see an approval, you should not touch it. You should ask for approval before you implement, because maybe it's not well properly tested, it's not well tested. Okay, maybe it's not. You need some final check, and if it's not approved, you should not run it. So that's something that takes some time to be implemented. You don't just wake up in the morning and because of performance issue, table size, you just say you have to partition. This is another project on that table. It can take days, weeks for it to be implemented. Weeks for it to be implemented. So that's why I don't want you guys to bother too much to go that deep. No, I want you to see how to create a partition table and how to identify partitions. That is what you guys need to know at this level. Otherwise, by the time you raise your head, I'll be far, very far. You will forget other topics. I can guarantee you that. So just grab the biggest concept and how to see. My goal will be for you to be able to create all these objects I'm talking about. I can create it, I can show you, but it will take more time. So by you guys doing it among yourself, it will be helpful for you, first of all, in the class. Any question before I move on?
Please, can you come back to hash partitioning? I did not quite understand it.
So hash partitioning basically is, unlike other partition, okay, Oracle does it for you. For other partitioning, you are the one to determine how you want the partition to be. But they want to say, for instance, for range partitioning, you are the one to say that, okay, I want a partition to keep value for employees hired between 2000 and 2010. You are the one to determine that. Does it make sense?
Right.
But the hash partitioning, you don't just determine, you just specify the column that has to be used as the partition key and the number of partitions you want. So how many partitions do you want? Oracle will take care of doing that for you. So in hash partitioning now, you will not say, oh, I want this value from this 1 to 1 and so on, okay? Hash partitioning, you just say, okay, use this column for my partition, and I want 5 partitions. And Oracle will have an inbuilt algorithm, and Oracle will automatically create those 5 partitions for you. You don't have to do anything. And Oracle will create them with the same size. They will have same size, even, okay? So you don't have to do anything.
All right.
Does it make sense?
Yeah, thank you.
All right, no problem. Question on this partitioning? You can keep your question if you have any doubt, okay? But with the presentation, I'm sure that it makes some sense as well, okay? I know your classmate will do better, and I will be there to monitor, so it's fine. Just to, brief you guys on this. Okay, I'm getting to the one of the most important feature on a query decision, the optimizer. Okay, let me ask question now, because I always like to see how far you are before I teach. What are the type of statistics you know in Oracle?
Optimizer statistic.
Yes, sir.
Database statistics, optimizer statistics.
Okay. That's it?
Okay.
That's basically the one I'm familiar with.
Yeah, I understand. Yeah, definitely right.
Yeah.
Have you ever heard of, Lucas ever heard of system statistics?
Yeah. System statistics gathered by the
Okay.
operating system.
Very good. All right. Very, very good. You know. Okay. Now I want you guys to define each of them. What is the optimized statistic? What are optimized statistics?
Another statistic is the utility that chooses the best.
No, sorry. Let me cut it short there. It's not an utility, okay? I want you to tell me optimized statistic content or whatever, okay? I don't know if you understand what I'm saying. Statistics are not utilities. Statistics are information, okay?
Okay.
So, yeah, you should not say it's an utility that gather or whatever, okay? Please, you can take a try again if you want.
Okay. Optimizer statistics is the gathering of statistics to know how much input, output, and memory are required to execute a SQL statement with a particular execution plan.
Very complicated to understand. Can you use easy word for that?
Excuse me?
I'm a recruiter. It's very complicated for me to understand that.
Okay.
Use simple word, right?
I
Go
mean,
straight to the point.
Can I try?
Because what you are giving is not actually what I'm looking for. I'm seeing some good point on it, okay? Some good information, but I'm looking for some keywords as well. Yes, you can try. Someone else can try. Let's see.
Okay. Optimizer statistics is basically the gathering of data from the database, which is used to choose the best execution plan for a query.
When you guys say gathering of data, what does it mean?
Okay, can I try again?
Sure, go ahead.
Okay. In simpler words, optimizer statistics are simply the statistics that are used to make decisions on how to access data.
Yes, that is very right. Correct. 100% correct. Yeah. What are they now? What are those statistics? I know they help. Now, you say they are helping. It's right. They help to do something. Now, what are those statistics now? What do you find on those statistics? That is what I want to know, right?
Yeah, those statistics, I believe they are just past queries.
Past queries. I'm not sure.
Okay.
Does it have to do with the count?
What are the optimized statistics? What does it contain? What do you find on optimized statistics?
Information.
Okay, the decision you guys are giving, if it's valid it's also very valid, okay, for a recruiter. You can say that it will make a lot of sense. But also, I want you guys to know what are those information. What are there's a job that gathers those statistics. There's a job that gathers them. And I want you guys to know that job. And I will not tell you guys how to go and research on that job. There's a job that gathers statistics, a package, it gathers them. Now, what do you find on those statistics?
You can find objects.
Yes. Yes, please. Can I come again? I did not get you right, please.
I mean, you can. I think you can find database objects.
Very good. Object information. Right?
Okay.
Object information. All the objects in the database, the table indexes, that is the usage. To do statistics, we keep the information about those objects. Okay. How frequently are they gathered by default?
60 minutes.
They are gathered every 24 hours.
Every 24 hours. Very good. By default, that's the default one, right? Very good. Very good. Okay. Why are they stored? By default. Why are they stored even? It's not by default. Why are they stored?
Data dictionary.
Very good. Very good, very good. Now you guys understand why in the life cycle we use some objects check if the object exists, the semantic and all those stuff, because that is where those information are stored in the data dictionary. Okay. Then now go to database statistics. What are they? Someone to try again. What are database statistics? What are database statistics?
Can I try?
Yes, please.
Okay, database statistics describe and give information about the data in the database. When I talk of data, I'm talking like the objects, like table indexes. So they give information about the data in the database, and they're used for performance. They're used to improve performance in the database.
Yeah, that's true. That's correct. So you think it contains only information about the data? Otherwise, that will be like if optimized statistics. What additional information can you find on the database statistics?
Like you have your like your parameters.
Very good, yeah. Memory matrix, right?
Yes.
The memory, okay.
Yeah.
The CPU usage, everything about in the database on the database statistics. So whatever is at the database level are found in database statistics, but optimizer are just at the object level.
Yeah.
Which background process connects database statistics, and how frequently does it do that?
I'm sure it's M1.
M1 every 60 minutes.
Every 1 hour.
What does M1 stand for?
Manageability monitor.
Are you sure?
Yes, sir. That's
Sure?
correct. It's correct.
Okay, good. Good to have confidence. How are they gathered? By default.
Sorry?
How frequently are database statistics gathered by default?
Every 1 hour.
Okay. Can I gather those statistics for less than an hour?
Yes.
Assume I want to collect those snapshots for an interval of 5 minutes. Is it possible?
Yes.
It's possible if you do it manually.
Okay. You guys ever try that?
Yes.
Which package do you use?
No.
It's possible, okay? You can do it on OEM or you can do it manually, GBMS.
I know I've done it.
Create snapshot. You can do it. It's very important. I will tell you that, the importance of that later on. Okay. Yes, very good. Where are they stored by default?
AWR.
AWR. Very good. All right. You have a quite good background. Okay.
Thank you.
All right, sorry. So now those optimized statistics we are talking about are stored in the dictionary, okay?
Yes.
So the optimizer uses those statistics to create the execution plan of the query. This is the component of the optimizer. Three component. It is good for you to understand it. I attended an interview. These people asked for this question. And the guy who asked for the question didn't even know himself. Yeah? Because in a very hard scenario, we see people who understand this, because sometimes we don't put too much focus on this. You know that the optimizer do create a plan, but you don't know exactly how it works in the background. And it's very important if you can explain how this thing works to someone. You can find more information, okay, on the documentation. That's why I told you guys I got everything on this PowerPoint is found on Oracle documentation. It's on one of the last slide. So you want, if what I said doesn't make sense, you can still go there and check, all right? But I compress it and it makes sense. Okay, let me take it very simply. Based on the statistic that I gather here every 24 hours, as you guys said, okay, the optimizer will rely on those information. It means that those information are like what? The optimizer statistic by default, what it has, for instance, the number of distinct values of the column, the highest value of the column, the lowest value of the column, the number of null value of the column. I'll talk about it when we do histogram on the following slide. So what happens is when you run your query, the first component of the optimizer transformer, the first component of the optimizer called query transformer, we take your query. Okay? And you will see whether it can create a better query than what you just sent. So you try, I can say in another word, you try to rewrite your query for you. That's what we call query rewrite. If your query is not good, so you try to rewrite your query for you, but with the same result. It's an example of that. For instance, you are issuing a query like this, but the query optimizer in the background can rewrite it with the second query. That is what it does. So we transform your query for you into a better query, okay? That's the first step. If your query maybe is poorly written, sometimes you can do that. But now, after it does it, it will send the result to the plan generator. So the new query that was rewritten, right? This new one now, the plan generator, which is the second component, will take that query and we create multiple options for that query. So multiple plan for the query. And for every single plan, the estimator will estimate the cost of every single plan. Once the estimator estimates the cost of every single plan, at the end, the same plan generator again will come and pick the cheapest plan, and that is what will be stored in the shared SQL area. Now, let me take the example with the Google map. I want to go to the White House. I don't know yet. I don't know the route. It's my first time. Most people, when they just came in US, they go there, right? No. So they want to go there. You want to go there for my first time. What I was watching on the TV, I want to get there. Okay. I type on the map. Type the address. White House. Google Drive does what? Google Drive, I don't remember, depending on how far you are, let's assume you are quite far, you are living maybe in, somewhere, a very long distance. Google Map can give you multiple options. Let's assume I'm in Green Bay and you are trying to go to there, you are going to go there, it's in GC. Google Map, you will type Google Map, White House. Google Map is like the optimizer. So Google Map will give you initially multiple options, okay? So that means you are making your request and you have now multiple options. So either you can take maybe 495 or you can take if you don't want to take the highway, you can take maybe Green Belt Road and you can jump to all those possible options without the highway. You want to avoid some highway. So you have multiple options and each of the options have maybe some advantages and disadvantages. Maybe if you want an option, a faster option, maybe you need to drive more. Maybe you need to pay the toll. If you want a cheaper option, maybe you need to, maybe you want to, if faster option, maybe you need to drive more miles. It's faster, okay, but you have more miles. Because you are going to the highway, right? More miles, and you have a toll. A cheaper option, maybe you will stay longer to drive because you have to go through traffic, but there is no, okay? There is no toll and so on. So somewhere you are gaining something, somewhere you are losing something. Okay, so you have all these possible options. That is what the plan generator will do. The plan generator will generate multiple options. Multiple options. to get to the same destination. Now at the end, it's true that you now will be the one to choose. So for each of the options the plan generator generated, we have one of them that is the best one that can suit your need. And now, once you choose one of them, it will be like the final plan, okay? The plan generator finally choose. Because the plan generator will generate all the plan, and the estimator will estimate the cost of each plan. And at the end, the plan generator will access all those and pick one. That is the one that will be sent in the share secret area. And that plan is what we call the explain plan. It's like the map, like this, what I just said. You are sitting in your car, you are typing Google Map to go to White House, and you choose one of the options. That option is what you will use, and we call that option the explain plan. Does it make sense what I just said?
Yeah, I have a small question. When you say we generate a cost, is it a cost in terms of memory use or?
Very good. Cost in terms of CPU. If I say a code is expensive, using more CPU. Does it make sense?
You break.
Huh?
I'm sorry, you break. I didn't get that.
When I'm saying that a code is highly using resources, it means it's using CPU or more memory.
Okay.
So if I say a code is a good code, it's because it can help me to retrieve the data, but without using a lot of resources. Without using a lot of CPU or without using a lot of memory. That's what I call a good code.
Right.
Does it make sense?
Yeah.
Yep.
A good code is not always a fast code. Not because if you have a code returning a result in 1 second, it doesn't mean it's a good code always. Be careful. A good code doesn't always rely on the time it's taking for the result to be retrieved. It relies on the amount of resources that code is using to return the result. So don't just think that if the code is running, that is what some assessment you have to do. If you can reduce the execution time, is good. But don't spend your time trying to reduce the execution time and increase the CPU. Because by increasing the CPU, it means that that code itself will be using more resources than other code. So that means other code will be lacking resources, right? Because of that particular one.
Mm-hmm.
Does it make sense?
Yes, sir.
Yeah.
Good. All right, are we getting a little bit how the optimizer take a code, a secret statement, transform it into a better query, and then try to generate multiple plans, and then at the end picks the cheapest one? Are we getting it, the concept?
Yes, sir.
Good. So that is how it works, basically. And before I come back on selectivity, okay? We talk about histogram, then you help me to talk about selectivity and cardinality. Okay, this is the last slide, so for sure I'm going to cover that, then we leave. So we just talk about the optimizer. And we talk about the optimizer statistics. And we say that optimizer statistics collect object informations, right?
Mm-hmm.
So, but those statistics are not enough for the optimizer to make the best decision. I also made mention, someone also made mention of system statistics.
Mm-hmm.
Because let's assume that I added more CPU on the server. The optimizer should be aware of that so that we know that, oh, I have more resources, so I can take advantage of that. Maybe we added more memory on that database. Maybe we increase the SGA size. Maybe we increase the total memory of the database. The optimizer should be aware of that. Maybe we added more disk at the operating system level. Maybe we increase the size of the FRA, all those stuff. The optimizer should be aware of those system statistics. That is why system statistics should be gathered frequently than optimizer statistics or database statistics. So you can gather system statistics anytime. Does it make sense? So the optimizer statistics may need this information to make better decisions, not just optimizer statistics, but also system statistics. Now, that was just a brief overview regarding the importance of system statistics. Now, let's come back to optimizer statistics, which describe object information. Do you know that those object statistics are still not accurate? Because those object statistics just store the total number of rows of the table. Let's assume the statistic of the table, okay? It just, on that those statistics, you have just this information. The total number of rows of the table, the total number of null values, the number of null values, the number of distinct values in the column, the highest values of the column, and the lowest value of the column. So meaning, let's assume I have a column called salary. So the optimal statistic will just tell me the total number of rows of that column, the number of people who have null, a salary equal null, that means 0 on that column, the highest salary on that column, the smallest or the lowest salary of that column, and the number of distinct values of that column. That means you have how many distinct salaries. Because people can have the same salary, right? But you just give the number of distinct values. But the optimizer statistic will not tell you the value on every single row of the column. So you will just know the optimizer will just know then the highest and the smallest value. But the optimizer will never know the allocation at the whole level. So let's assume that we have salaries, people have $1,000, other people have $1,500, other people have $2,000, that's the highest salary. So that means on the optimizer statistics, the optimizer will just know 1,000 and 2,000. The optimizer will never know those who have 1,500. And because of that, the optimizer will just make an estimate of the number of rows that your query can return. And based on those information the optimizer has, you try to create a plan for your query. And that plan may not be accurate because the optimizer doesn't know the distribution of the rows on that column, distribution of values in that column. So that is why we come with what we call histograms. Histograms are additional statistics at the column level. So once you decide to create histograms, it will help the optimizer now to know the allocation, the distribution at the row level. So, in addition to what are found on the optimizer statistics or system statistics, now the optimizer will be able to know the values on every single row. So the optimizer can make better decisions while trying to create an explain plan for your query. I created a demo. I sent it to you guys. Histogram demo. That was for this purpose. It was a 12C database, okay? Even on 11G, you can still use it. So let me explain the demo so that when you guys are reading it at home, it makes sense. Are you ready? Are we getting first the biggest concept of histogram before I get to the notepad?
Yeah, you can proceed, sir.
Yes, sir.
All right. So now let me explain it with this demonstration. I think you guys have it right. I sent it right. Histogram demo.
Yes.
Okay, good. So what happened is I logged into a database as a user, okay? Maybe I did not assume that I'm a DBA. I log in as a user, and I assume that this user has a table called two tables, T1 and T2. And T2 is a copy of employees table. I did not want it to, bother that much. So you guys know HR the employees, right?
Yes, sir.
The employees, yes. So you guys know that table has 107 rows. So I just created the table T2 as select. So you guys know how to create a table as select. So this is, for instance, a table with a number of rows. This command helps you to know the information found on the optimizer statistics for every single column. I just told you guys that the optimizer statistics provides the number of distinct values. So meaning that on the column employee ID, we have 107 distinct values. That is normal because employee ID is a primary key column. Everything is unique. So it's normal that we have 107 distinct values. First name, we have 91 distinct values. Last name, 102, and so on. Department, 11. The optimizer statistic will also tell you the number of null values on every column. So for column employees, we don't have null values. For first name, we don't have null values. And so on. But for commission percentage, we have some people who don't have commission. For management, we have 1. For department, you have 1 null values. The lowest value, please, this one are calculated by Oracle, okay? So Oracle knows how it's going to assess the lowest value and the highest value. So this is what the optimizer uses as lowest value and as highest value. And we all know how to get the total number of rows is just 107 based on what you did on the select. So that is what the optimizer can have. But the optimizer doesn't have other values or anything else than that. It doesn't know any other value than the highest value or the lowest value. But now, this other column is just to tell you that before on my demo, histogram were not yet created on those columns. That's why the value is none. So meaning when I queried the user underscore tape underscore calls, I did not have any histogram yet created. Now, because I did not have an histogram created, whenever I was issuing select count from that table where department ID is called 50, the count, the real result is 45, but the optimizer is seeing only 10. This leads me to what I call cardinality. Before I come back here, I will explain how cardinality works. Cardinality is basically the number of rows that will be returned to the user. So when you guys issue select star from Scott.emp, you guys have a result, right? And below that you say 10 rows return or so and so on. That is the cardinality. And the cardinality is actually calculated by the optimizer. Okay? This is the real formula. Cardinality is equal the total number of rows times selectivity. The selectivity is actually defined. This is another formula, okay? You can see selectivity is number of rows, total number of rows returned, and okay? So that means cardinality is the number of rows returned from the query. But I want to tell you how the optimizer calculates its selectivity based on statistics. So, because cardinality is equal total number of rows times selectivity or multiplied by selectivity, for the optimizer to know how selective a column is, the optimizer uses its own formula. For the optimizer, okay, selectivity is equal 1 divided by the number of distinct values of that column. That is how the optimizer thinks. When Oracle is sending the product, that's how the optimizer thinks. So for the optimizer to know how selective a column is, we do 1 divided by the number of distinct values of that column. What does it mean? It means that the higher this number is, it means that this ratio will be closer to 0. If this number is smaller, it means this ratio will be closer to 1. Are you getting that one?
Yes, sir.
It's correct, right?
Yes, correct.
Okay. Meaning, we said that a column is highly selective whenever the ratio is closer to 0. Those are the best type of column to create indexes. So that is why if a column is highly selective, it's more likely for the optimizer to use the index. If it's not that selective, it's more likely for the optimizer to use not to use that index and to choose another option. So that means the optimizer has a unique formula to calculate the cardinality or to calculate the number of rows that will be returned from that table. Now let's get back to our example. This is the cardinality column. This is what I call an explain plan. This is the kind of thing I'm expecting the group to create. An explain plan has this column. This column is cardinality. This is a basic explain plan. This is what we call cardinality, or you can say rows. And for the table called T2, the optimizer made its calculation and find out that the number of rows to be returned is 10. How? How does it know that it's 10? Let me show you. Remember, on the table employees, the total number of rows is 107. Correct?
Right.
The number of distinct values. Now, let's know what's the number of distinct values. What are we querying? We are querying where department ID equal 50. So which column is involved? Department ID. What's the number of distinct values of department ID?
45.
Number of distinct values of department ID is 11. Can we see that?
Yes.
This is the column number of distinct values. So on the department ID column, we have 11 distinct values. So meaning the optimizer is going to calculate the selectivity based on this formula, right? 1 divided by 11, because 11 is the number of distinct values of that column. That's why you see here, cardinality now, based on this formula, is equal to the total number of rows, which is 107, multiplied by the selectivity. And the selectivity itself is 1 divided by the number of distinct values, which is 1 divided by 11. And once you do this, is equal to 9.72, which is closer to 10. That is why for the optimizer, the number of rows that should be returned is 10. But the reality is 45. So meaning that the optimizer is making a wrong decision. This is just a small table. Imagine a big table. Maybe you will not see the impact on the cost because it's a small table. Imagine a table of millions of records, and the optimizer makes this bad decision. Your SQL statement can choose the worst option ever. Now, this is without histogram, because we can see here that the values is none, no histogram created. Now, and without histogram, I can see that they are not matching. The real count is 45. The real number of rows that should be returned is 45. But what the optimizer is seeing is 10. So it doesn't make sense. So it's not reliable.
Quick question, sir.
Yeah.
What SQL statement are we supposed to issue to get that execution plan?
To get that execution plan, we just issue this command. I will explain that, the different way of getting the execution plan. Okay? I will explain. Okay, that is the next session. I'll definitely do that. That is the PowerPoint right after statistics These are the one way of getting the explain plan. Okay, we talk about this. Okay, good. So that is why you got it, because you not just issue this query. You have to set auto trace to get it. Without this command, you could not get this one.
Right.
Okay. So this result was without the histogram, meaning I did not have additional statistics on those columns. But now I decided to create create histogram. This is how we create histogram. It's like you are gathering additional statistics just for those columns. This is you specify the table name and you just say if you want for all columns, size. Now you gather this thing. You can check now. You will see now that the histogram, the none is just for the primary key columns because the histogram are not created on primary key columns. Okay, they are created on non-primary key columns. That's why you see none. And histogram have two values. So we have on 11G, we have frequency and high balance. And on 12C, we have frequency and hybrid. Now, if you see frequency is valid whenever the number of rows on that column is less than 256. 256. So meaning the total number of rows on each column, distinct value on each column, the number of rows on each column here, you can see that the highest value is 107. So that is why all of them are frequency. But if you have some values that are more than 256, then you will see here hybrid. Okay, so whatever is below 256, you will see frequency histogram used. Okay, and more than that, high balance. So they do the same job. Now, with this scenario, an histogram was created. We can now see whenever we are querying that histogram has been created. Now, let's issue the same query again. We enable auto trace, we issue the same query again. Now the optimizer can see the exact number of rows as the count, because the optimizer now has additional information than the regular optimizer statistics. So we can see that the histogram actually help us to get more fine-grained information of every single column. Are we getting it?
So can you come back to it again? I didn't quite get it.
So what happened is, without histograms, that means when I issue this query, histograms were not yet created on the column. You can see the value none.
Right.
And without histogram, the optimizer was just relying on this information as I made mention of, the number of distinct values, the highest value, the number of new values, and the lowest value. And because the optimizer was relying only on this information, the optimizer could not make a good estimate of the number of rows that should be returned by the query. Because the optimizer, based on its own formula, determined that only 10 rows should be returned. But the count is telling us that normally 45 rows should be returned. It means that if you are issuing your query, only 10 rows will be sent to you. That is what the optimizer is thinking of. So it's not accurate.
Right.
So now it's making a wrong estimate because it's relying only on what it has. But now what happened is, I now created an histogram by using GBMS gather stat. Once I created histograms now, the optimizer now can use both optimizer statistics and histogram now to make a better estimate.
Right.
I now see that the estimate number of rows that should be returned is even equal to the number of rows to the reality. So this plan is more reliable than the previous one.
Okay, sir. Thank you.
No problem. Does it make sense to everyone?
Yep.
Yes, please, you can go home and you will check that as well, okay? It's easy, you can try as well, okay? You can use any other table and try. I use employees table, you can use any other table. And if you guys want very good demo, because I'm not doing demo anymore, I advise you guys to use a schema called SH. This guy has table with 10,000 of rows. The schema is called SH. So meaning that those who are creating indexes and partition and want to see how important they can have an effect, either you can create a table, you make it become bigger so that it make more sense, okay? So that it has thousands of rows, or you can use the SH schema. So you guys can just change the password, okay? You guys remember this, after user SH identified by, you guys have done this, okay?
Yes.
Unlock at the account. Okay. And once you unlock it, just for you to set the new password. And once we connect to this schema, SH schema, the guy has very big table. And one of the tables I mostly use for my demo is a sales table. This table has more than 100,000 rows. So by you guys creating indexes, it will make more sense for people to understand. Does it make sense? Or partitioning and doing stuff. Please, I recommend you guys to use this table while you are doing your demo. For those who have to use the command line, okay? Keep this one in mind, SH schema. It's on 11G as well.
Okay.
Yes. All right, so let's learn to the final part, explain plan and education plan. This is why I stopped with the morning class. Let me take the same example, the destination to White House again. I just told you guys that, I told you guys earlier that if you want to go to the White House, you tap your GPS, right? And the GPS will tell you the possible option, and most of the time, it will choose the best one for you. And that's what you will use based on the parameter you set on Google Maps. So once you tap your GPS, normally it's advisable to research the destination before you drive. That's the recommendation. I know that most of us will drive before we type the destination, right? So, but you should normally type the destination on your phone or at home, access it, know the direction before you start driving your car. That's the normal way of doing things. So now, once you do that before you start driving, we call that an explain plan because the optimizer created a direction for you. You just have to follow. That's what it's a plan. It's like a plan. You are building a house. It's a plan. The engineer will make a plan to build a house. You are trying to do anything, you make a plan. Okay? So it's just, can I say? It's just some predictions. It's a prediction. It's predicting that you build your house before the end of the year. It's predicted that you will get there by 30 minutes. The next 30 minutes, you will be in a White House. These are just predictions. That is what the optimizer tells you. Prediction on how you will get to the destination. Prediction on how the server process, on how long it will take, on how many resources the server process will use. Those are just predictions. It doesn't mean that the server process is actually going there yet. That's what we call explain plan, because the optimizer will just create something like that and give it to the server process, and the server process now should use that plan to go to the data. Now, we call that explain plan. Now, you are taking your car, you are driving. You are going to the White House, following the plan that was created by the optimizer. Same thing, the server process is taking the plan and going to the buffer cache or the disk, okay? Now, you can follow the plan and you reach out to the destination within the specified, within the predicted time frame, right? If they say, okay, you have to take 495 and you will get there within the next 37 minutes, you can get there within the next 37 minutes. It can be accurate. It's an option. but you might get there earlier or later. Let me take the worst scenario. It's true that you had a plan of how to get to the White House. But imagine you are going to the 495 highway and suddenly there's an accident. Before, the optimizer did not see the accident because there was no accident at that when you were typing the GPS. But while you were going there, an accident occurred. What will happen? Because the optimizer has information, because Google Maps has some information, along the way, Google Maps can change your direction. I can choose another route for you to get to the same White House. Now, things are changing. What was predicted before is no longer what is used, because if you still want to follow the prediction, you may stay there longer. Because maybe because of an accident, the police or whatever, they close the road, right? You have to take another route. So along the way, the optimizer now will say, oh, the Google map that behaves like the optimizer will say, oh, actually the route is closed. If this guy takes just other route, he can get to the destination. It's true that the prediction I gave to him or her was 30 minutes. I know that now he can go up to 32 or 33 minutes, but it's still better than him or her waiting on the traffic. Now he will find another alternative and you can get to the White House. Those alternatives, whenever you are taking your car, driving till you get to the White House, is the execution plan. So you are actually following the explained plan to get to the location. But the explained plan can be equal to the execution plan if there is no thing that happened, right? If there was no accident, the explained plan would have been equal to the execution plan. But because something occurred, now the explained plan is different from the execution plan because of that accident. Because now, instead of following the initial plan that was provided to you by the Google Map, now along the way, you decide, okay, Google Map gave you some other information or other alternative to reach out to the same destination. This is how it works in Oracle. So the server process can start following the explained plan. But at some point along the way, Oracle may receive more up-to-date information and the optimizer can affect the decision or can affect the existing plan that the server process was using, and the server process may not follow the initial plan and can follow another direction. That is what we call the execution plan. You are executing the plan, but it can be equal to the initial plan or it can be different from the initial plan. Does it make sense?
Yes, sir.
All right. So that is how it works. So if you want to know how a SQL statement accesses the data, you should rely more on the execution plan than the explained plan. Because maybe it never followed that explained plan. So the execution plan gives more reliable information than the explained plan. An execution plan is stored in the VDollar plan table. While the explained plan is stored in the... They can be equal, but they can also be different, based on the example I explained. Simply because along the way, Oracle can get more accurate information, and that will affect the way the SQL statement is executed. All right, we are done for today. Any question? Any doubt?
A suggestion for Monday. You said Monday will be starting at 5.
Oh yeah. Sorry, yes. Monday you'll be starting at 5, please. I finally tried my best, especially yesterday, to affect my schedule, but it looks like it doesn't depend on me because we are dealing with people from India and most of them as well, they are part of multiple projects, okay? And I could not find a better time that will help everybody because they could not change their schedule, you know? The time I try to, you know, to tell them to bring it back to bring back the meeting to 4 p.m. To 5 p.m. I'm sorry, to 4 p.m. but they could not.
So is there a way that you can share the link from the morning class from the group so that, you know, even if someone come in late in the evening, at least they can probably listen to first part in the morning? Because
yes, of course you should have that flexibility, okay, to attend either the morning or the evening class. I think even from the morning group, I saw somebody ask for the link for the evening group, and it was provided. So your class admin can also do the same, okay? Or because in the morning I'm not the one to post the link. In the morning, there's somebody who has the account. When I join the meeting, he just, you know, give me the ownership, give me more control over the session. So he's the one to own the Zoom account. Does it make sense? He's the one to have, because he was unable to find the credential to give it to me. It looks like he created his, when he was creating a Zoom, right? It looks like he used his personal Gmail. And if he gives me his personal Gmail username and password, I can access his email. It's not good. So that is why he's the one to launch the meeting. And when I join the meeting, I can just make me become the host, and I can just proceed from there. So in case you guys are interested, I can just do that easily. Just copy and send it to you while I'm getting to the session, if you want to. Okay? Okay. I don't have any problem doing that.
Okay, I'll just make a request when that time comes.
Okay, no problem. Yeah. I start with them. With them, it varies a lot. Like this morning, normally I was supposed to start with them at 11, but I had a conflict again, meeting at 12. I could not start at 11 and take a break before. No, we started at 10:15 so that we not waste too much time. So we started at 10:15, and when we got to 12, they took a break. I went to the meeting and I came back around almost 12:45, and we proceeded till 2 p.m. So it can move. They just have to, even you guys, if you guys can also, no, you guys, I will keep it 7, okay? So that you guys don't change your schedule frequently. But we will start from next week at 5, sorry, I said 7, I said 5, right? 5. We start at 5, and we should end before, we can end around 8 or 8:15, it depends, okay? But we should start at 5. That is the best thing I was able to do. If you can also work on something, I can make 5:15, 5:20, but I cannot go above that, above 5:30. I cannot go below, above 5:30. That is the best thing I was able to find. So sorry, I know that it will not work for everybody. I really apologize for that. But that is the best thing I was able to find for you guys.
Thank you.
I'm not sure it's going to last like that, okay? Because those are just
Thank you for being with us.
It can change, okay? But for now, I want us to get used to this schedule. But in case it even changes, I will try my best to maintain it so that we are used to the schedule.
And thank
you decide to change something at your workplace, you don't need to change it again because of me. Okay, so I really apologize for that. I don't know. We can just try our best to work with that schedule. Yeah.
All right, thank you.
So, yes, I think before last class, when we were doing the introduction, I wanted to ask you, since you work with Oracle,
yeah,
and you've been in the business for some time now, what are the certifications that will be more, that will give us more, like a better chance of getting good jobs?
Yeah.
Aside from the OCA, I guess.
Yeah, good question. Yes, I am OCP certified. I am also OCI certified and very soon Exadata certified. For the last class that was class 24, when I was preparing for OCI certifications, I sent them all the dump because to prepare that, I had to test most of them. So most of them are certified in OCI. Most of them are either autonomous or OCI DBA. Most of them, depending on, it was free because Oracle launched something like that, a free program. That was me. And once I passed all of those stuff, I just shared it down. Okay. And most of them now are OCI. And at the other free, they even extended it till July. I think it's already expired now. Extended to July. I was not with you guys on July. So, but once I share it, it's something that was supposed to be shared. I was not part of that group yet, right? So once I share it, normally I know some of you may have friends on class 24 who pass something like that. So whenever I get in touch with a certification, I will always share, okay? I will never ask for money for anything. I'll just share and you just go and take that, okay, and try. The OCA is a very good certification, okay? Normally, by now, all of you should have passed the SQL exam. Because the SQL exam is like the prerequisite for the OCA. You can pass the OCA without the SQL exam, but you will never get the certification. You never get a certificate. So it's good at your level, a 5 years DBA should have an OCA. Very good for you, it's a good point. The OCP is for more than 5 years, normally 8 years and so on. It's not mandatory, but if you have the option, you find somebody who can provide you a dump to pass it, it'll be also something good. So for any Oracle product, the OCA is a good starting point, or if you want to go higher, the OCP is very good. Once you have the OCP, is good. It's a good point. And we all should know that our salaries sometimes depends on the level of the certification we have. Somebody who has an OCP certification can decide at some point the minimum salary he or she wants. When I have the OCP, I can decide whether I don't want less than 100K again or I want more than 100K. Because to get an OCP, it's more professional than OCA. Okay? And again, it can affect the way they will pay you. I remember one of the jobs when I got the first job, I got only the OCA. And I had a guy who had the OCP, still from Brontech, but it was not in my batch. And the way they proposed the salary to him was more than mine. Even just the way the HR talked to him, it was different. We are not equal. He's OCP, I'm OCA. We are not equal. I mean, he has more hands-on, more experience than me. Even though we see 6 years or the number of hours, it doesn't mean anything. That means he knows more than me, and then he needs more. That is valid for diplomas. Somebody who has a bachelor and somebody who has a master are different. I will not pay you the same, I will not give you the same salary. So those certifications affect salaries, basically. Okay? They are good pluses. I will encourage you guys to pass those exams the soonest. Okay? But in case I get into a dorm, because those stuff change frequently, okay? I will just take your group. You guys will go and take a try. But it will be good for you to take it. Okay?
So my question is, like, for the OCP, for instance, if you go in and you're just like a brand new person into the market, and then they ask you questions about the OCP, and you're unable to answer, or okay, let's say for instance, you go and you pass the exam.
Yeah. No worry, they will never ask you any question about the OCP, okay? They just tell you, check whether you are certified. Do you think the OCP are passed and know everything on it? No, not at all. Sometimes you pass something not because you know all of that, because you are just lucky to pass it. You don't need to know everything. They will never interview you because of the OCP. Your interview won't be that difficult because there's OCP. No, the interviewer and the HR are different. So don't worry about that. Even when I gave the OCI to people, and I never told them to go and study the OCI. I even gave them the AWS certified associate. Myself, I have it. When they pass it, I just gave them a story. If somebody see that on your resume and ask you, do you have experience on AWS? It's very simple to tell the person that, hey, I studied AWS and I passed the certification, but I don't have hands-on experience. At least for them, they will not interview you, but they will know that you know, they will think that for them, they know that you have some knowledges, some theoretical knowledges. They may not even interview you. So for them, it's easier for them to train you on AWS. Just tell them that reality, that you just studied. Don't lie that you worked. Because whenever they say you worked, the interview is different. The way they will interview you will be different. So you don't need to understand everything to pass a certification. That is how it is. You see people on internet, whatever, they have 10 certifications, 50. Do you think they are expert on all of them? No. Okay? So that is how it is. So if you can grab a dump and you can understand even just 50% of that area, you are good. And you move forward. Okay?
Nathan, does it have the expiration date? OCA
Yes,
or OCP?
yes. OCA has an expiration date. I think OCP also has. Okay? Some of those certification, the expiration date can go from OCA especially is 2 to 3 years. I think it's 3 years. OCP also is about 3 to 4 years. It's a lot. It's quite long. It's just the OCI that is very dynamic. That can be a couple of maximum of 1 year or 2 as well. So, but there are expiration dates, 2 years one. But you, what do you need? You need to get it so that you have more chance to get the job, right? That's it. Once you get that job, if you want, you don't even take it anymore. It's up to you. But because the IT world is evolving, you always have to study to take certification. So yes, it has expiration dates. Are we good?
Yes, thanks for the insights.
All right. Okay, guys. Thank you. Enjoy the rest of the week, okay? We meet on Monday. Okay?
Thank you.
All right, thank you.
All right, thanks.
Mm.